Hello, hello, hello. I hope the music is fine. I'm trying something new. It's Dark Souls. It's music from Dark Souls because I don't wanna sleep, but at the same time, okay, I don't know. Let me prepare the link. Boo, 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 boo. Um, okay, should be good. Do, 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 do. Okay, here we go. Here we go. Do. Okay, things appear alright. Hello, people. It's me, once again. Never gonna let you down. Always gonna be streaming. Last time we had something that was working. We had this, right? We can generate like a terrain. We have collisions also. So like if I try to go down, I'm gonna get blocked by the colliders, right? Like this. It's working well. I don't like how I'm a capsule, but why not, I guess? And aside from this, what do we have? What do we have aside from this? Well, I mean, the goal was to optimize this a little because it's still like very not fast. Like performance-wise, we're like less than 30 frames per second. And what is that? Wait a second, what is... I thought I fixed... Can't create buffer of size 0. Oh, okay, no, that's fine. Is because now I have that. And this is going to be the goal of this stream, actually. The goal of this stream is to offset what we just computed here. So there. We want to take this and bring it to the GPU, to a compute shader. So that's going to be a lot of work. I guess I'm going to create a new file. So rendering, it's not really a render pipeline, but you know, it's something, I guess. For now, I'm just going to put it there. Opaque past data. I have nothing there. Cap. Yeah, I'm just gonna create. So how are we going to code it? We're going to code it to generate vertex buffers or something like that. Technically, we can already have our index buffer. Like generate buffers from faces, maybe. Or like a buffer generator. Pipeline. Maybe it should have pipeline in the name. Yeah, pipeline is fine. So something pipeline. A vertex generator pipeline, maybe. Okay. Boom. And then I'm just gonna bring it here. Actually, just the CPP. The H is gonna be here. Okay. Okay, so we have this. So pragma on. Let me copy this. So I guess it inherits from node. We can do the same. For now, just this. Vertex generator pipeline. Boom. Okay. So then we have our different buffers, right? So I guess we want like an input and an output buffer. Or multiple output buffers, actually. So I guess we're gonna have one of this. Well, kind of. Here. So we have the faces. I'm just gonna remove all of this. So we have, I guess these should be the outputs. Those are the inputs. Well, there's just one input, but that's good enough. And we have maybe a process function. I mean, I should be able, well, I should set those things at one point, but yeah. Let's have a pre-process, maybe? Prepare, pre-process, I guess. Maybe not. I mean, I should basically be taking faces, right? Which are from this. I don't like how I can't forward declare it because it's in a class. Let's just have a process for now. And it's gonna be vertex generator pipeline. Here we go. You know what? I'm gonna include this. Let's go fast. No need for hesitation. And let's remove the cables from the top of my keyboard. Perfect. So modules, voxel, core, base. Now we have something like this. Base. This is gonna be local vector, I believe. Yep. I mean, it could just be a pointer, like a simple pointer would be fine too. But I guess we can have this too. Faces. Who? Right. So we have the faces, okay. Now let's create what we actually want, which is our IDs. Here we go. Rendering device. Wait, it's not. It's there. No, it's not. Interesting. Here we go. So we have all of that, and now we want to put some data in it, right? The faces.ptr, I guess. Null, uint. I have to cast. Yeah, that's fine. Here we go. I'm not sure about the usage flags, but yeah. Yeah, okay. It's a pointer, right? Wait, it should not be const. But it's creating a... Oh, it's a span, right? Something like that. Wait, I can actually just do span. Oh, that's pretty cool. That's pretty cool. But it's still not working. Uint 8. From phase to... Why is it so troublesome? So PTR. I'm gonna convert that to bytes. So bytes. And then I basically want length. That sounds good. Okay, this is good. This is good. So we should be setting the default things. Then we have the storage buffers. Maybe it's gonna have to change in the future. Like, you know, vertex buffers and stuff. But for now, compute shaders is fine. And I guess I want to create my compute shader pipeline. Let me remove this. It's not really useful right now. So what is it going to need? The shader, which is this. And is that it? Specialized constants. As a default. Pipeline specialization constants. I'm not sure about this. I mean, I guess we can remove... we can remove all of this. To have create buffers. That's gonna be private. Uh, Span. I mean, it doesn't matter right now. I'm just gonna move things like this, okay? It really doesn't matter. Hey, why am I first on YouTube again? I've been in 15 minutes. Whoa. You're so fast, that's why. You're Batman, aren't you? Here we go. It's already been 15 minutes. Oh shit. Yeah, time flies so fast. I hate it. Time flies so fast. I haven't started doing anything really. I mean, I guess I technically started, but yeah. So then we have the shader. Well, the pipeline. We need to load the shader, and at the end we have. Do we need like a list? Because I can't just dispatch compute list. Yeah, I need my compute list. I need to send my uniforms maybe. Well, attach my buffers, I guess. Okay. Okay, yeah, I get it. Okay. What about inject? Threads? Wait, what's the difference between X, Y, Z? Oh, you can specify the threads with this one. Like in X, Y, and Z. Inject, you have a buffer, and you set an offset. And here you have groups. Groups instead of threads. Well, I'm not sure what the difference is. So GPT, go to compute, oh wow. Compute shader. What is that? Dispatch indirect threads. Dispatch versus dispatch indirect versus dispatch threads. So this is the standard way to do things. It dispatch into multiple groups. I guess the shaders is kind of the same, but instead of, well, groups is threads. Let me start with the threads instead. This one is not part of Vulkan. Oh. So it automatically converts that into work groups. Wait, what? Becomes this. So it's basically Code instead expects you to do this calculation yourself. Yeah, there with the dispatch. So this is fine. Okay, now the last one, indirect, which is like, I do want to do indirect draw calls because that's like the most optimized, I guess, but it's not a draw call right now. It's just I want to run my compute shader. So instead of the CPU specifying the work group count, the GPU reads it from a buffer. Oh. Okay. That's interesting. Yes, the result is the same. And if I compute shader, I can write those values. Yeah, it's like not really needed for me. Yeah, I mean, not for this though, is it? Okay. Anyways, so I guess I'm just gonna do a dispatch. Compute list dispatch. So I'm gonna have the list. I'm gonna have groups. I don't know at all what I should have for those groups. Like 444. I don't know. 16. Anyway, we have the list. So the list is gonna be something like rd create lists. Complete list. Wait. Actually, that might not be that. You know what? GPT. Create Godot CPP. Create a compute shader pipeline as an example. A whole. And dispatch it with inputs and outputs buffers. Here we go. So let's say we have this. We have the rendering device that we don't have to create. We have the shader file that we load. I wanted to steal that from my other pipeline. Let me reduce the volume a little bit. So create pipeline. Okay. Then we have the create input data. Well, I mean, yeah, that's like at the beginning, right? That's when I create my buffers. Okay, I have this, I guess. Output I have, well, I'm creating it already. Create uniforms. Can I take the size of my buffer in the shader? Maybe not. I guess I might need a few uniforms. That's fine. Then begin compute list. Compute list begin. Oh, that's the name of the function. Okay, let's do that right now. So compute list begin the name. Then we have the bind. So RID, is it? Wait. What's this? Here we go. Then we bind compute pipeline, this. Compute list, yep. I guess pipeline. Here we go. There's nothing else. Then we want to bind the uniforms. And because when I bind the uniforms, I'm gonna bind the buffers with it, right? Yeah. Maybe. Yeah, okay. So I guess it's like compute list bind uniform sets. And the index. Right. So I mean 0, I guess. It doesn't really matter. Process, we could say. We have the uniform set. We're gonna have the pipeline. We are gonna have the shader. To do load shader. And to do create uniform set. Technically. That should be it. No suitable conversion function from RID. Wait, I wanted to pick up pipeline. Let me look at this because I have the read back. And it's for texture get. It's this, right? Yeah, there's like a OID. Yeah, okay, this is fine. Okay, so I can like differentiate between the two readbacks. That's good. So why is it not compute list? Yeah, I need the list. Okay. So set, then I dispatch, and then I finish the list. Complete list. And there was something else here with a draw command begin label. So I might want, can I have a label? Begin label. No, I guess I can't because it's like a compute fader, so I guess it's, you know, you can't really debug it the same in RenderDoc. So I understand that there's maybe not any label. Okay. Then I submit. But it's supposed to submit. Yeah, in my case, Godot is supposed to submit the thing. Right? Like I draw, I end. And I guess that's it. So I'm not sure whether it should be like good by itself or not. I think it should be fine. Without put and then cleanup. Yeah, I guess we want some cleanup. So can I'm playing this game that is a team strategist game, but whenever no help me, what? But whenever I'm the killer, they help everyone else until I'm not killer anymore. That means you're just too good at the game and that they're just all working against you. You're just too good, man. Can I have a callback for when the compute header finishes? Nope. Shit. So yeah, we have sync. We can pour. Technically, I guess. Yeah, I mean, I'm not supposed to get it back on CPU right now. I'm supposed to send it, but for like debugging purposes, I want it on CPU for now. Yep. Compute. Read back. Native. I guess technically. Current pattern is to write the compute job yourself. Q. Then in your update loop. Triple buffer the output. What? Wait. I'm just gonna go back here. And texture get data async. Technically, I should be able to do this, right? Like for all buffers, which is not the best, right? But I should technically be able to do it. So like vertices is the most important. On vertices, read back. Oop. Right there. And I guess I can do that with all buffers, really. Boom. Okay. So right now we have like one thing. Has no... yeah. So right now I'm just gonna do that with vertices because that's the most important. Has no member. Okay. Okay, it's good. I mean, I don't actually even have to make it a node because I'm never gonna check it inside the editor, right? So I guess I'm just gonna remove this. I'm just gonna remove this. It's not a node. It's just my own little class. Okay. So now we need the shader. That's actually the most important thing. It's actually going pretty fast. Well, it's been like half an hour, but yeah. For later. I mean, I guess I don't really want to remove the RIDs right now. Read output. Wait. Uniform, create uniform, and that's the uniforms, and we have the shader. So load the shader. Right. Let's take a look at what we had for this one because that's gonna be that good. Create shader. Well. I mean, I guess that's fine. Technically, we could just copy this. Follow and subscribe, right? So it's just gonna be pick up shader. I'm just gonna copy all of this, really. For now. Shader path. So this is gonna be a copy. I mean, I'm never actually using shader file. Well, actually, maybe later. Right, wait, I need the shader path. Yeah, I don't really like that. Maybe I can have it like in the... wait, what? I don't understand. And binary. Well, it's just 101010. Wait, actually, no. Let me translate it. I don't think it means anything, but I'm still translating. Convert. Yeah, it's nothing. I don't understand what you're coding, but it seems like it's going to be peak. Oh, thank you. Yeah, basically, right now, I mean, I can show you already. Right now, don't mind the errors. I have my world right now, right? Like you can see, I have like my blocks. It's like a bit big. Right now, I also have some collisions, but it's like very, you could say, slow. It's trying to do too much, and like my FPS is not good. So my goal is, instead of trying to load a chunk every frame and doing that on the CPU, I want to move that to the GPU. So I can multi-thread it. So it doesn't stall my frames. And you know, so it can run in parallel and my frames can be fast still. And I guess so it can also optimize it a little bit. Do you know what like the difference is between CPU and GPU? Resource loader load. What is that? Incomplete. Yeah, that's why I want to actually use it. Hey! Sucks, hello, how are you? I'm good. Can you show the donut Minecraft world again? I want to show the projects to my little brother. Oh, yeah, sure. I actually have the game open. It's like going pretty slow right now. Like, as a FPS is like pretty low. But we have like some basic collisions now, at least. Like we can walk on the ground and we can just go down, right? Right now, I guess the altitude can get pretty high, right? We have like big mountains. There's still no lighting, no proper lighting. But it looks like this, and it's like slowly generating, and you can basically like turn around. So these are the collisions. But yeah, it's like generating around. It's taking some time, but because I guess I have like more chunks, well, more blocks and stuff. But yeah, it's like slowly making a donut. As you can see, you can turn around. You can create, for example, the little, a little tower, you could say, right? And I can move. Oh, you added more vibration in the terrain. Yeah, basically I had a bug that was limiting the generation to the first chunk in altitude, in Y. So I decided, you know, to increase the altitudes for debugging, and I just haven't reset it since then. Last time I saw it, you just had the donuts. Yeah. I mean, I think I did have... Yeah, sorry, it's like freezing a bit from time to time because I'm going very fast. We have like some problem with the terrain here, right? The separation, I have to make it wrap correctly. But yeah, now we're back at our little tower, right? We see it. So I guess it's like pretty hard to see the donut now that we have the mountains, but now we can see it like a lot more clearly, right? It's still generating, but it's a bit more clear. And I can also, like if I add a lot of blocks like this, you know, I'm showing it to your little brother, but if you continue putting blocks like this, it's basically going to bend, right? As you can see. It's not straight. So yeah, I guess that's it. Trying to have some funny geometry. And now we try to optimize this. And then we are going to add like trees, like, you know, vegetation, like try to make the environment a bit better, I guess. Maybe some water, maybe, you know, like improve the generation. And then we're going to start adding some gameplay and stuff, I think. I still have to finish the collisions too, but yeah. So that means it's actually going to go pretty fast. So yeah, I guess you can't really understand things pretty easily right now. Well, I mean, with the mountains. I'm just gonna generate our fdiff. Let's put that to 5 maybe. Oh, that was the default. Yeah, and now you should be able to see the donuts a lot more easily. Right. It's taking more time to generate because it's trying to generate chunks that are in the air now. It wasn't before. I should like kind of skip those. But I guess that's how it is. I mean, technically I can skip them. I can add like some kind of optimization for that. But yeah. Well, basically it's like this, right? I mean, I would still have to fill them with air right now. Yeah, I mean, I can optimize things, but yeah. Now it's like a real, you know, donut, well, with like a bit of an elevation, but good enough. Ah! Wait, what? Wait, I don't have collisions there. Why is that? Huh. Interesting. I have collisions there, I have collisions there. I don't have here. I don't have here. Oh wait, I do have collisions there though. Not here. But here I do. Oh, okay, maybe I have a little bug, but that's fine. That's something to fix. Okay, so yeah. Right now the code is to make a compute shader to generate the chunks asynchronously. So resource loader, do I have this? Not yet. Wait. Is it? Nope. Core IO resource loader. Resource loader, here we go. Okay, so we load. I need the correct path though. I guess I need the shader file. Boom. Servers rendering binds. Rendering binds. Here we go. I don't really want to print it every time though. Something very unfortunate happens. My dog fell off my bed and now he's limping. Oh no. I hope it's not too much of a problem. But I hope he's going to be fine. Okay. So I guess the shader path. I'm just going to have it like as an input in process for now. in boo. Then I guess I can do this for now. Then we have the create shader, I suppose. Well, I guess I'm gonna create it every frame if I do this. I guess, yeah, I guess we need like a prepare function. Something like this. Right. I guess the input faces might differ. Yeah, I guess I'm still going to create the buffers here, but that's alright, that's fine. Also, I signed up for a voice acting for an indie animated show, and I got accepted. Oh, GG. GG. Well done. That's good. What kind? So I'm gonna create the shader here too, right? I guess the pipeline too, technically. So I'm gonna go there. Uniform set, create the uniform set. I'm not sure about this. I guess we want to create the buffers, though. Animated flip it clip or something. We got a full team working on it, though. Oh. Oh. Nice. Yeah, when I picked Dark Souls music, I thought it would be like a bit more dynamic. It's actually pretty chill. Yeah, does anyone has like a game with like dynamic music? Like, I don't know. Like Endless Battles. Like, I mean, right now I think about Evoland for some reason. I mean, I guess technically, can I use the soundtrack from Evoland? I think I had some problem with copyright. But okay. For now, let's just keep this. I wanted to change a little bit the music. It's good enough. It's nice. So then we want to create the uniform set. Okay. Let's go there. Create input data, storage buffers, create uniforms. So uniforms. You know what? I'm gonna create uniforms directly there. Okay. So all the uniform. Oop. I guess we're gonna have multiple buffers, right? So we're gonna have faces. Pet uniform type is gonna be RD storage uniform type storage buffer. Then we have the bindings. So binding is like 0, I guess. And then we have add ID. And this is the ID of, you know, our buffer, right? like the faces or ID. That's one. Oh, my head. Uniform. So then we have a bunch of things like an output, for example. So kind of the same, I suppose. Like vertices uniform. Gonna be 1. You're gonna have vertices RID. It's a storage buffer, and we basically have one for every buffer. So that's going to be a lot if I continue like this. But yeah, I mean I can just loop also. I could have RID buffers equal faces, all of this technically. Whoop. Boom. Hey, Axaver, how are you? Bonsoir, did you try using Claude? I started testing it a few days ago. I mean, I don't feel like I really need it. Like, I'm pretty good, you know, the way things are. Basically, I just need, like, an AI to like, show me, like, the syntax and, like, you know, the functions I really want to call. Because I can't remember, like, everything all the time. And, like, you know, like, I guess there's, like, a few details, and I want to make sure I don't forget, like, to call, like, I don't know, draw a list, begin, or, you know, that kind of stuff, right? And aside from that, yeah, just something to ask questions. Well, some kind of Google, I guess, that can search on internet to tell me like very simple questions, like things I don't know, but that can be answered pretty easily. Like, for example, what is the most optimized between something interleaved or not? Like a buffer that is interleaved or not? Wait. Yes, the music is getting a little too excited from time to time. The main expansion, Infinite Line of Code. Oh. I'm using it to make a roguelike game, doing Monte Carlo simulations and everything. Oh, I hate writing code. Oh, okay. I mean, I guess the problem is like very. Okay, it was very loud. So basically, the problem is because, you know, a lot of people try to make some kind of Minecraft games, you could say. But the problem is, if I want to let everything to AI, it's gonna go to like the easiest, the most simple code. Like, for example, I guess it's gonna assume that you're kind of like a new programmer also. Well, also, almost. And it's gonna like tell you to do things like on the CPU and, you know, like very basic things. But the problem is that right now my problem, for example, is optimization. So I want to optimize, right? But, you know, it's not gonna optimize out of the blue from the start if I just let it do everything. And on top of that, I'm doing like something a bit special. Like I want like some custom geometry and stuff, right? And in this case, like the architecture would not fit. Like the architecture it would come up with would not fit. So like I'm doing a lot of architectural work. But yeah, I mean, for like the render pipeline, for example, that's something kind of easy to, you know, to kind of make, I want to say. you know, I'm kind of using it to make sure I don't forget any function and stuff. Yeah, that's the annoying psycho fancy fact. I don't know what this is. Psycho fancy. It's a fancy word. That's how I have to say. That it makes assumptions and then implements stuff without asking. But it turned out that's vanilla behavior, and I've modded it away. Oh, I mean that's good. Yeah, well, by modded it, what do you mean by that? Do you mean you have like extra instructions, like on top of your inputs, or do you have like extra waves? Do you have like how is it called? A LoRa. I mean, I guess you don't really have a LoRa for LLMs, do you? I mean, it might be possible to increase memory, but there's a memory MD. Yeah, okay, so it's like just adding an additional input at the beginning, I guess. May I explain how it should behave? Yeah, okay. Yeah, I mean, I guess, you know, I could do that too. But I mean, even with that, I feel like it's gonna... Like, for example, just for the donut, right? For my distortion, it didn't succeed in doing it correctly. So I have to do some math myself, I guess. Or like some math myself. I guess I would have to dig, right? But I don't know, you should test it. It's very impressive. Yeah, I mean, I guess I haven't used Claude, you're right with that. Yeah, you're asking me about Claude and I haven't used Claude. So, is it like Claude Code? Visual Studio Code, well, Visual Studio, can you just add it? Install the official Anthropic extension for a native AI agent. Okay, now I'm actually thinking about how much my computer is able to support. Because I'm like streaming at the same time, right? And I have not a lot of memory left. But I mean, why not? I might try to use it one day. Because I guess I haven't really used LLMs like integrated in my IDEs. Like even a Copilot, I'm not even actually using it. So maybe it can be like a nice, you know, thing to try at least. Thanks for that. Damn. Yeah, memory-wise, like my computer is like a bit dying. I should like move that to my external disk. Some stuff, at least. Anyway. So we have all of this. What do I do with those? I ignored AI until Linus Torvalds said it increases code output by 10 times. Then I started testing it. Yeah, I mean, I think it's fine for some stuff. I mean, I do think it's, you know, nice in some ways. By that, do you mean like by letting AI write? Or do you mean by using AI as a tool for the developer to code? If Linus says that, I listen. Yeah, I mean, I'm also thinking about, like, for example, with Godot, they have like a big problem with a lot of pull requests being opened that are just, you know, like that contain code made with AI, and apparently, like, it's a big problem. It's a big bottleneck. You can use it how you want. Personally, I'm not touching any code. What? Okay. Yeah, but I mean, how would you say would be the best way to use it? Because I guess you have like AI agents that I actually kind of want to try, but I feel like it's just going to spit bad things. And my teacher said only use AI or you're a failure in my class. What? And that was all of our grades was used AI to make games. What? Almost every time I tried to load up ChatGPT or Gemini, he would have me get in trouble. But that's what we're using to make the games. For my school computer, it has no memory, only 2 GB. Okay. I mean, the problem is if you're not using a model that's like big, it might be a bit bad. Like it's going to be worse, right? Usually. Personally, I just use natural language to describe what I want, and I check strats. Oh, stats. Check stats. What's changed? Stats. Yeah, right now I'm just, I just have this. And basically I'm trying to adapt. So like I have my uniforms, okay? But then I want my uniform set. So I'm gonna have this with the array. And yeah, I'm gonna create it. So yeah, I mean, this is pretty simple thing. So array, uniforms. I'm gonna do for buffer in buffers. Technically, I can have a copy, I guess, because it's just like an integer or something. And then I do uniforms that push back. To uniform. That's binding. Right. E++. So then I have buffers I. I have I, that's gonna be the binding. Oh, right. Oh. What was it? I think it's something like this divided by size of or ID. Okay, then I push back and then it should be good. I should have like all my uniforms and stuff. Wait, what? Push back. Oh, the uniform. To const variant. So it's not really working, isn't it? Yeah, I guess that's like one case where AI is kind of wrong. But maybe with Claude it would have been better. Like, that's very possible. So I'm gonna create uniform set create, uniform buffer create. What is that? Never mind. That's good. So you have this. We want so it's a vector view. Then we have the shader. We have the shader set. I forgot what it's about. I mean, 0 is probably fine. So I guess we have like the uniforms, shader set. So it's like 0. Oop. Uniform set equal this. And I guess I want a vector. And a vector of the uniform. Is it good? It's not. View, can I? Vector view, the uniform. Oh, right. Wait, that's a bit different, isn't it? That's a different type. It's a ref counted. Yeah, that's like a completely different thing. Right, I forgot it was like failing this too. Set, append, type. Okay, so technically what I want is this. And uniform type equal this. Binding equal id append a set. I guess set is fine. Wait, what? P. If P is not 0. Huh? I don't get it. Wait, I'm just gonna look at how I did it on my other pipeline. Oh yeah, right. Monte Carlo. Yeah, okay, I see. 36 from Monte Carlo simulations and so on. So the code itself is a black box. I'm only looking at code when hunting for hard-coded stuff. Got it. I mean, I'm letting the AI show me things that could be hard-coded or whatever. Yeah, I see what you mean. Yeah, I mean, that seems nice. I mean, I do want, like, ideally, I guess, I would want, like, some AI agents to code things and, like, try to, supervise in, like, some kind of, like, as some kind of lead, I guess. While still being able to, like, create the tasks, assign them. And I guess I want things to be pretty specific, but I mean, I feel like it's going to use things like Godot 2. As in Godot, like you have vectors that I don't like. Well, I mean, never mind. No, it's a me problem. There was a tornado warning yesterday. Oh. I didn't get one. I mean, we're like in different places, but I had like a lot of typhoon warnings recently. Okay, so let's go to pickup. You're gonna have the uniform set. I'm actually not. Oh no, I actually have it. Append ID. Wait, what? Texture sampler. Oh, right, because in the case of a texture, you have the sampler and you have the OID. So that's why. Okay, in my case, I only have like one append ID. I only have one thing to add, so append ID should be fine. And it just buffers this. Okay, here we go. And then uniforms push. This is going to be RD uniform. And then we can use it to create our uniform set, which is great. And I guess I just want to ensure that this is correct. Condition. Fail count. Like this. And if this is null, this is not good. Then what do we have? If any of this is null too, it's not good. Like actually face audio should not be null. I mean, nothing should be null. I mean, that should be good enough because they're being created at the same place. Okay, so we have all of this. So we create the buffers, we create the uniforms. Then we bind, and then we do stuff. Okay. I mean, that's actually mainly it. That's actually mainly finished. It's because I live in Florida. Oh no. Crocodiles. Mm. So now, where am I going to use this? Where am I going to use this? In the chunk space visual. Cube chunk space visual, actually. Maybe. Yeah, I already have this. That's good. Vertex generator pipeline. Build, Excel. Rendering. Boom. So we have this. Okay, okay. Not bad. Technically, I can have the shader path in here. So like pipeline shader path, something like this. So like with a getter, a setter, and like I should be able to set that in GDScript. Yeah, I'm procrastinating this a lot, but I'm just gonna have to do it. I still have this. Oh my god, that's so obsolete. Cube chunk. Wait. Yeah, space. That's fine. So set. Well, that's gonna be a bit too much. Set vertex gen shader path. Then we have the get vertex gen shader path. Shader path. This. Get boom. And string this. We have the getter that returns. I guess I can optimize, like I can write this faster with AI. That would be nice if the AI could just write my getters and setters. That's something that's like I don't really like with Godot, because like in Unreal you just have macros, right? In Unity you just like, yeah, in Unity you just have attributes. Within Godot you have to write it manually, which is a bit of a shame. But I mean, that's... I was gonna say that's fine. No, that's not. That's not fine. Boom, string. Okay, should be good. So now we have all of this. Instantiates chunk visual. I mean, technically I could like just run it, like initialize it the first time. Maybe that's going to be a bit like a small spike, but that's fine. Okay, so we have this. I mean, technically I could just do it in the constructor, can I? Can I? Is it a problem if I don't do it on the same thread as the rendering? Oh no, that means I need like a compositor. Wait a second. So yeah, I'm using AI for that too. But the question is very simple. It's just that I don't know. I'm basically Googling things, but with ChatGPT. And this is... I want to run a compute shader to create buffers. To create vertex buffers. Should I run it on the same rendering device as Godot's rendering pipeline? The answer is yes for that. I think like I'm 90% sure that this is a yes. But I'm giving some context basically, and then the actual question is gonna be: do I need to run my compute pipeline in this rendering thread too? And I think it might be a yes. I'm not sure about this. You should use the same one. Yep, I know. And yeah, it should run on the rendering thread. Yeah. That's gonna be a pain. I mean, technically, with my debug things, I do want to read back, so that might be fine. But yeah. What? Yeah. Wow. Mm-mm-mm. So I guess I'm gonna need a compositor, technically. Is it trying to run everything though? If I do it using the same rendering device, is it going to try to run the compute shader like for the frame? For the frame? And stall if it's too slow, instead of doing it in parallel? Oh yeah, it's only when I need it. Oh yeah, because I guess the frame has like a weight for the output texture, right? Yeah. Yeah. Yeah, it can overlap, I guess. Yeah, okay. I mean, technically, I guess it's fine if I don't actually need the texture, right? Hmm. Technically, it's like the same with my pickup buffer. Well, I mean, my pickup is like evaluated every frame, so that's a bad example. Hmm. So, okay, I guess this is not a big deal. What was I trying to do again? So I have this, and what I want to do is go in my cube chunk visual, and when I rebuild, so I had this, I can remove, and there I have like the GPU. Instead, I'm just gonna call space, cube space, something like this, please. Space, okay. Oh, I have, yeah, space visual is actually better. Space visual. I'm gonna have this. I'm gonna maybe prepare. Right, I don't have that. I mean, my architecture is not the best right now, but the goal is that I should be able to modify it pretty easily. Because at least things are in the right classes and stuff. Well, kind of. Oh wait, that was actually shared path. Yeah, okay, this is good. And then I process with like my different faces. And I'm just gonna do ball is prepared. And I'm just gonna return whether this is valid or not. Wait, actually, whether the shader, or the pipeline, whether the pipeline is good or not. Okay. So now I can do this on demand. Well, only when needed, I mean. If it is not prepared, I do this, and then I just process. Okay, process. I mean, technically it should be fine. I just need like a valid shader, I think. That was actually pretty fast. That's like a bit surprising. Wait, dispatch. Let me just look at an example of a shader. So this. So we have the in. And then there's ID, global invocation. Yeah, so I mean, I need the... Yeah, X. Local size X64. So what if I want to do it for like every face? Like Chada, what if I want to loop over every element of the inputs buffer? Because I think local size x has a limit. It can't be like more than a certain value. Should I have a loop, or should I increase local size x slash the amount of groups? What's the best? Because I guess I want like a middle ground between the two, and I don't remember this. Every element is independent. Don't write a loop. Instead, launch one invocation per element. Then we dispatch. Oh, right. Yeah, never mind. I guess I can do that. Every thread needs to process the entire buffer. No, that's not what I want. A reduction. Choosing local size X. Okay, this is it. How many threads cooperate in a work group? These are the defaults. Larger isn't always better. There are hardware limits. I mean, it shouldn't even be like that big, right? You almost always want one GPU invocation equal to one voxel. I suppose. Or one cube. I mean, it's gonna be one phase, but yeah. Except for like fluid simulation and stuff, maybe, but yeah. So wait, process each element independently, increase work groups. Not local size. Yeah, so local size has like a maximum basically. But the work groups is like, can be pretty high. Max amount of worker groups. Typical minimum. Oh. Yeah, I mean, I shouldn't have like that many faces anyways. Wait, am I? 50 times 50 times 50. 1 to 5. Ah! Well, I mean, if I have like 16 in local things, that should be fine. I mean, that should be fine. Many threads. Yeah, I have multiple threads. Wait. Never mind. Huh. Yeah, 64 times this. Yeah, I mean, this should be enough. I hope. So, I mean, I guess it won't be able to be completely flexible, but that's fine. Okay. So yeah, dispatch. Wait, what is that again? That's the amount of groups. Yeah, okay. So groups. 1, 1. I guess 1, 1. I guess I just want something in X. is going to be like divided by local size. Yep. Voxel count. But I mean, I want to... Okay, for now, I'm just going to have faces that size. Okay? So I don't have like multiple threads and stuff, I guess. But that's gonna be enough for now. Do multiple threads. Anytime I look at you, I think of Dr. Donut. Dr. Donut. I'm the Donut Man. Okay, so I have the dispatch. It's been 1 hour and a half already. Okay, we have to finish things fast. So let's restart. So now I want my shader. I'm gonna make it in the engine. Oh, I need to run this on like the rendering thread. Oh yeah, that's gonna be bad. Yeah. Pick up. So okay, I have all of this. Well, maybe I don't. Yeah. So much Ghost card. Okay, so what about the compositor? Right. Camera sets compositor. Huh? Oh. It's because it's not an object. Oh no. I mean, technically, I don't even want the thing to be here. I don't even want the thing to be here. And the callback to be here. I guess I'm gonna maybe take it as an input. I mean, technically, I don't even need this right now. Yeah, I'm just gonna remove it. I mean, I guess I'm gonna just open my game. I don't have a folder for my... I don't have my game folder right there. And maybe... Projects. Voxel game, here we go. Ah! Okay, it's already here. So shaders. I'm gonna have pick up GLSL. I'm gonna copy this, and this is gonna be vertex generator. Maybe. Or like vertex gen. Okay, I'm just gonna open Visual Studio. So now I have this here. Oop. Okay, good. Wait, oh, right, it's in shaders. I have this. Huh? Shader file. Huh? 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 Wait, what? This is not... Huh? Anyways, I'm just gonna go there. And I guess I'm gonna... Okay, this is gonna be my first compute shader like this. So I don't actually know if it's going to be good or not. But I have my faces, which are... I actually don't know anything about this. Compute shader example with custom struct inside first buffer. Yeah, can I have what if it's int 8? What if struct contains int 8? I think I just need like the operator, right? But int 8 in GLSL, it supports, but only if the device supports them and you enable the extensions. Or I can pack bytes into a uint. So I have the packed and then I unpack like this. Yeah, okay, that's what I was thinking about. I don't need two operations actually, but yeah. Oh no, I do actually, because I convert into a uint. Okay. Okay, so I guess we're gonna do that. C++ struct must match the shader layout. Wait. Marching cubes. I don't want marching cubes. Not now. So, okay, so we have compute. For 5, we have layout local size x equal 1, I guess? Because we want only one thread because of the amount. Maybe not. I don't remember what I want. That's fine. So then we have vertex inputs. And I guess it's like faces. We have faces. This is 0. And this is going to be an int, like uint. Right? Faces, well, uint should be for the best. So that's one. What did we have after this? I love that. So we have out vertices. So in faces, let's say, out to vertices. So it's gonna be like 1. Oop. So vertices, what are they going to be? Wait, when I create the buffers, it's like, okay, I have it. So vec 3. Then we have, wait, UVs is vector 3. That doesn't look right. Let me just go back to here. 3, 3, 2. Okay, let me keep this. Oh, actually. So I'm just gonna copy that. I'm gonna go to here, paste temporarily. So 3 UVs is 2. I guess I don't have the normals, but I want them at some point. Custom. Float. 32. Triangle. It's int 32. Quad. To cube int 32. Face is uint 8. I guess it can be an array of bytes actually. Wait, if I have an array of bytes, how can I get it in the shader? Oh, but anyways, does not match. What? Right. I mean, I can just remove this, right? Yep. Okay, so this should basically be good. And then we maybe have the normals. So, I mean, let's say this is... No, actually the normals like cost so much, I want the normals there. Normals or ID. Normals or ID. Would be good. And the second is gonna be the normals. So now we have out normals. We have out UVs. Out custom 0. Out triangle indices. Quad index to cube index. Quad index to face index. Woo! Good. Something like this. And I just need to set the right types. So vector 3, this is 2, this is float. Out triangle int 32. Well, it's an int, I guess. And those ones are... This one is int. Can I have a int 8? I can't. Okay. GLSL bytes. Does not have a native byte or char. The smallest basic type is 4 bytes. So I guess I should have like an array of integers and do stuff. I'm trying to get every 4th of July skin before they leave, and my dog just trying to jump on the couch, but he missed because he's limping. Oh. And I guess it can be integer. And that means that this is going to be... What is this going to be? I mean, I guess it's like times 4 anyways, right? So in some way it's good enough. Yeah, you just have to access it in the right way. Okay, so should be good. So now let's go back to the rest. So we have a lot of vertex input. Wait, what? Wait, that's not really what I want, is it? Well, it should be like this, I guess. So I should get something like this. And I guess it makes sense because in this case it's like just some kind of, it looks like a uniform, right? Yeah, it's like a mistake not to interleave everything, but it's fine. Read only buffer. Okay, let's do that. So layout. Actually, this. We have the... In every case, the set is 0. Set equals 0. And then we have the binding. Yeah, because it's like not a vertex shader, right? So it's like not like this. And in every case, all of this, it's read-only buffer. Vertices. Like this. I guess. Is it? I guess it is. Vertex input. Yeah, no, that's fine. Okay. Oh, wait, do I need like a padding? Oh, no. I think I'm gonna need some padding. Am I? Maybe not. I don't know. I mean, I guess not. Never mind. I'm not gonna have padding. Okay, so we have this. I guess I want the same for normals. And the rest. Wait. Normals, which is 2, 3, 4, 5, 6. And we need 7. Yeah, this is pretty bad. Oh my god. Okay. This is integral. Then we have truncal indices. Custom 0. Flat. Should it be a flat actually? Is there any reason it's a flat and not an integer? I don't think there is. Then we have the normals. Wait, UVs is like vector. Okay, should be good. Then we have the main. We have all of this. We have ID equal. It's not OpenGL, so what is the equivalent in Vulkan? Is that the same? I guess it is. Invocation id.x. Then we have the inputs. So we have like the face. Oh no. Faces. 0. Okay. So we have in faces ID, technically. Okay, so let's say we have all of this. We have the face, da 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 da. And then we want to decompose the face. So let me see the chat. Okay. How long have you been streaming? It doesn't tell me. Tonight for like two hours only. I made one of my boyfriend very scared. Never asked him a question, a simple question. If you're really dating her, what is her favorite color? He got scared. Oh, he didn't know. Yeah, I mean, that's fine. My friend's boyfriend. Yeah, I mean, okay, I understand now. I mean, it's fine, like, favorite color is not like I don't even know what mine is, right? So I'm just gonna decompose. So uint, we have x, we have y, we have z, and then we have the face ID, or index. And we're gonna decompose, so it's basically going to be face, because I have to move it. I mean, I guess basically I don't even have to move this one. This one I have to move it. Then we have 8, 16, 24, I guess. Oop. 24, and it's like 0 FF. Well, wait. Huh? It's not working. Wait. FF. F. Okay. So packed. And this is... Yeah, it's supposed to be something like this. I guess the highlighter is just not detecting it, IntelliSense. So fill. Good. And this. And I mean... It looks pretty scary, but... But what? You? Yeah, why you? So... Huh? It does look scary. Didn't know you swore. Yeah! Fuck! Yeah, I was actually thinking about that a lot when I saw it. But yeah, I'm actually not sure that this is right, because let's say you have FF, so it's like 4 bytes, right? Like you have 1, 2, 3, or 4 bytes in total. And I guess what you want... Oh, U for unsigned. Is it? Wait, what is that? Because U is not even like from A to F, right? Yeah, I think it's unsigned. So, okay, I know that makes sense now. And it's a 32-bit unsigned integer literal. Yeah, this is good. I didn't know you could actually have them together. And yeah, hey, Dana. So now we have all of this. So the goal, Dana, I'm gonna explain it. If the music is like not too loud. So basically the goal is, right now we have our game, but it's like very slow. I don't even think I can run it right now, but it's like basically kind of very slow. And the goal is to basically, when we generate the faces and like the vertices for my chunks, before I was doing it like on the CPU. Right now I still do it on the CPU for now, but I first compute the faces and then compute the vertices and all of that stuff. And as you can see now, there is no condition anymore. There is no if anymore. So the goal is just to move that on the GPU. I'm just gonna move that on the GPU. And it's gonna be good. And it's gonna be fast. And it's gonna be async. And my frames are now going to be like very fast. Very, very fast. Vroom. So that's good. That's a goal. I'm gonna run into a lot of issues, but you know, that's part of the game. Yeah, let me actually just look at this, because I guess I actually want to implement this here now. So I have X, Y, and Z, and I'm just gonna copy what I had on the CPU. So the size of this is good. So for each face, so I have one face, local vertex indices, face normal. Okay, you know what, for now, so for one face, I'm gonna loop 4 times for each vertex. Makes sense, right? So I'm gonna have out vertices. This is gonna be id times 4 plus I, right? That way we can have, well, we can set like the vertices directly in the buffer. And this is gonna be equal to something. Let's say it's just gonna be equal to something. Then we have UVs, customs, and I guess that's it. Out UVs, out customs. Yeah, I mean, I guess this is fine. So custom is just the quad index. What is the quad index? Plus plus at the end. So it's basically just ID. Oh, wait, I actually don't even need this. I feel like. Well, that's fine. Oh yeah, it's needed for the index buffer. Because of the index buffer, right? Okay, so we have this. UVs. It's just const UVs. Okay, so it's... Can I have something const vec2? Const UVs. Is that gonna work? So it's vec2 0, 0. 2, 2, 2. 1, 1, 1, 1. So now this is just this I, which is fine, which is pretty simple. And now this one is like gonna be a bit complicated. I actually might need another uniform for that, because I need the chunk coordinates and the size and so much thing. Ooh, so many things. So what is the position? It's position of this. So I'm gonna have vec3 pos equal x, y, and z. And this is gonna be pos plus chunk cards times chunk size. Yep. Plus const vertices. Right, it's offsets of the vertices. So let me actually call it like vertex offsets face vertex. Well, face vertex to offset. Wait, what? It's 8. Oh, right. That makes sense. That's it. Something like this. And then we have something very similar, but with one there. And yeah, it's actually the same. Good. Simple. Else. So I have this. I do the plus. I. Wait, there's... Oh, that's not good. It's not I. It's local vertex indices. Ah. Oh, that sucks. So I basically have also this, it seems. And I need to do this for some reason. I don't know why, don't ask me. Wait, that's like a double array too. Oh, right. No. Okay, I get it. It's because there's like the face index. And then I have this. And then I do this. Sorry, I'm gonna look at the comments again. Nice. I'm trying out 3D in Godot. I almost finished the Blender donut tutorial one time. The donuts, again, everywhere. But otherwise, I don't know much about 3D. What do you want to know about 3D? I mean, I can tell you. Like, do you want to know about rendering, about collisions, about math, about... What do you want to know? Animations, skeletons? So, yeah, that's a problem. Can I have GLSL to the array? I don't think... Yeah, you can have matrices, but not really, right? Hmm. I can't have pointers either, right? Can I? Oh, actually, I can have uint4, right? So like uint4, or like vec I vec4. Oh, here we go. We can have this. Because it's like constant. I'm not sure if this is like proper syntax, but you know. Hey, here we go. Looks good. Looks good. So now we have this. So we have I vec4. And now we can just loop. I guess, I hope. I mean, I still have to take those as like, maybe I should like take them as like push constants, probably. Hmm. So, okay, I have this. What else? Times block size. So all of this times block size. Chunk size. Yeah, okay. So times block size. Something like this. This should be good. Vertex index plus plus. Yeah, I mean, this is fine. Can I do something like consts? Just to make sure that it's like optimizing, or I don't know. Okay, and then we have the... Wait, do I want the indices? Do I have the indices here? Triangle indices. I actually do. Incredible. So for all faces, how many faces are there? Wait, what? What? What is that? 6? Huh? Huh? It's not the amount of faces. It's the amount of vertices. What's that? Okay, I'm gonna replace it. And it's... Well, yeah, let's just have int I equals 0, and then 6 plus plus. It's like the amount of... Yeah. So it's basically one quad, and this is 2 triangles. So we have triangle indices, id times 6 plus I equal, well, index offset, this is, wait, actually, that should be this, right? Plus face indices k, wait. And what is that? Right. Boom. I don't like that. I can't have a vector for this one. I mean, technically I can just have, I mean, the best would just be to have like an array, like a simple 1D array, probably. So like, let's say we have this. So it's this. So it's a plus I in the end. And this is this times 6. ID times face index. 1, 2, yeah, times 6, I guess. Plus I. And that should be good. I hope. I hope. Well, actually, 1, 2, 3, 4, 5, 6. Yeah, okay, this is good in this case. In this case, both are like going up to 6. Okay. So now I can... Yeah, this should be the same, really. But well, we're just gonna have this for now. Boom. So we have triangles. Wait. Right now I'm trying to figure out what's the simplest way to make trees and bushes. Ooh, without touching Blender. Oh, oof, oof. Okay. Oh man. Oh, poor man. Oh, poor man. So... I don't know much about 3D. Yeah, so I guess the first thing to know about 3D is that you don't use engines to create your assets. So yeah, I guess you have to use Blender. I'm sorry about that. I mean, technically in Unreal, they started adding a lot of in-editor tools to like modify your meshes and stuff. And like even like your skeletons, like your animations. I guess skeletons too. In Godot, you have like your skeletons and stuff that you can modify in game because it's just like a hierarchy of nodes. But for meshes, technically you can create meshes using the like a mesh builder, I guess. But that means you have to provide the vertices yourself. You don't have like an easy editor inside the engine to like modify your model and do things. Right now I'm using as a sprite to draw the textures and then use CSG shapes. I guess you can do that. Basically in 3D in Godot you have, well, even in Unreal you have in Unreal you have your meshes, but you also have BSP brushes. In Godot it's like similar. You have your primitive 3D, I think, something like that, and you have the CSG shapes. But you have to keep in mind that the CSG shapes are basically supposed to be used as placeholders, or like they're supposed to be fused in the end, because I think it's using SDFs to be able to be modelized pretty easily, and that makes them very easily like you can subtract a shape with another shape, and you can have like combinations like this because it's like SDFs, and then the goal is that you fuse them together to create a mesh that is fine for, you know, a released game. I mean, yeah, I guess you can use that. I mean, if you want I mean, I guess usually like bushes, like plants, like on the grounds, like grass, you can use planes, I guess. That's like one way to do it. But yeah. I mean, it depends on what you want to do. I'm not sure what you want to do. If it's like a big bush, if it's like, you know, just grass. Okay, and in the end we have, I mean, I can generate that on the CPU. Okay. Oh. Quad index to cube index. So this is face index equal. Let me actually think about this. Can I actually? Can I write? What is block index? It's like XYZ. It's like pause, basically. Wait, is it? No, get block index from. Oh, right. So it's like x plus y times any blocks dot x. Right. Plus z. Wait, let's see. Wait, what was it? So it's this plus z times 2 this times this. So then technically I can use those together. Wait, that's not how it works. Yeah, it is. But I just need the times y to be here. Okay, should be good. So this is technically what we want. I'm not setting the normals right now because I first want to make sure that I'm writing things correctly and stuff, because to write the normals, I'm probably going to need to apply like the batch, and I don't really want this. Anyways. So I guess we have this, and the last one. Yeah, I'm not sure about that. Face index. Quad index to face. Quad index to cube. So this one is like a bit more tricky because it was supposed to be uint 8. So I don't think I'm gonna be able to write into it like this. Well, that's pretty stupid, isn't it? Okay. No, that's fine. Huh? Yeah, that's pretty unoptimized. But I guess I can optimize this later, right? I at least want to have the shader work fine. So I'm just gonna modify things a little bit because right now it's like an integer, right? And that means I'm gonna have to modify this into a proper 32 integer. Something like this. And that also means that here, just to make it a bit, wait, actually, am I using this? Texture storage buffer. Huh? Oh yeah, because I'm packing this, right? Probably. Dot size. Yeah, it doesn't actually matter, does it? For now, I'm just gonna replace it to like a 32. I don't think it's going to change much. AI viewers, no AI viewers here. Wrong target, wrong person. So we have this. And that should be good. And now I'm gonna run it and it's just gonna crash. Actually, let me make sure that... Wait, I should be able to... Huh. Let's get things. String vertex gem is like the right class. Interesting. Shadow path. Right, it's a bit big, but okay, and chunk space. Wait, is that the wrong class? Wait, it actually has no script. Wait, what? Chunk space visual. Cube torus chunk space visual. No, this is fine. But for some reason it just doesn't have... I guess it just had the method. I guess I just have to restart actually. That's probably it. So now the goal is set the path of the compute shader and see if it runs correctly. If I can make it run. And not even retrieve the data, but just to run for now. How has nobody been here? It has been at least 30 minutes. It's because they're on Twitch. They're on Twitch. At least 30 minutes. I mean, technically, I guess I can change this. Can I just do this too? Nope. I mean, we can try this. I think there's like a problem with... But basically, I'm treating them as unsigned integrals instead of signed. But that shouldn't really be a problem. Mm-mm. 2, 5, 6. I'm trying to think how I can pack things. But well, now 2 people are watching. Oh, so many people. Oh no, 3 people. Oh. Whoa. I'm so popular. And it's not showing. What's the problem with this? Output build. Cube chunk visual. Nope. Yeah, there's definitely a problem here. But I don't know where. Because I'm supposed to have like all of this. Okay, so it's cube chunk space visual. Torus chunk space visual. It's like inheriting properly. Is it that it's actually just not added to the registry? Visual, space visual. No, it is added correctly. I average about 1% per live. Oh no! Hi, oh, hello, Ringcraft, how are you? Not gonna lie. What do you mean? Yeah, I just don't know about this. Let me try cube, well, visual here. Can I do this dot path? So I have the get. Then shadow path. So I have this. But for some reason I don't have the set. And that must be why it's not showing in the inspector. Because that's like invalid or something. The get is fine. The set is not. Are you that notch guy? I'm not. 4 people are watching. You guys will never different me. 1 person is watching and that's me. Oh no. No, there's more people watching. Don't worry. Don't worry. I have a lot of bots too that are sending me cheap viewers apparently. Maybe not, because I'm not clicking on those links. I'm just hallucinating you. What, me? Like the other people. Oh, that's why. Like the get and the set are like inverted. Why are you here? Wait. So let me just fix this first. That. Okay, now it should be good. I hope. Okay. So now we set the path of the compute shader, then we try to run it, and then we see at what, well, we look at what fails, which is going to be a lot of things. Maybe, maybe not. It should. Okay. And I guess I'm going to try to replace the vertices first with like a read back or something. So this. Hey, here we go. Okay, so now we have shaders, vertex gen. Ooh, should be good, right? I'm actually not sure. Pipeline. Yeah, it's local. So that should be fine. What about if I reimport? Okay, there's a problem. The problem is that I don't know what the problem is. Error importing. Okay, you know what? We're gonna try to run. Perfect. Perfect. Buffer, too many storage qualifiers. Oh. No. Too many storage qualifiers. What do you mean? Oh. Buffer, too many storage qualifiers. GLSM. Likely mixing conflicting keywords. Buffer uniform. Huh. Maybe. Oh, it's in, I think. Yeah, I think the problem is it's the in. Let me just take a look at what GPT wrote earlier. But I'm almost sure that it's the in. So like read only. Yeah, there's no in. Okay. So we're gonna remove this. Boom. A lot better now, maybe. Okay, let's try again. Still some problems. Oh, I have to reimport. Wait, actually no. Constructor cannot convert parameter 1 from free component vector to 2. Wait, what is it? 46. 0, 46. Okay, 46. There. Oh! Wait, what? Face vertex to offset. Face vertex. Wait. Huh? Wait, that's like... I guess it's supposed to return vector freeze in this case because we add. And like if I look at my code, which was phase vertex, right, it's pause after chunk size. Pause, chunk size, this returns vector free. Yep. Okay. Let me reimport just in case. Wait, how? Yeah. Okay. Okay, let's try again. Yeah, okay. No, not supported. 87. Yeah, I mean... Wait, what was it? Boom. It was 87. Oh, this. Yeah. Yeah, this one is very bad. Wait, I have it multiple times? No, I don't. Okay, that's because of the control F. Boom. One less problem. We still have a few of them though. Boom. Undeclared. Okay, now this is getting to the good part. Now I need push constants to push the chunk cards and a few other things, I suppose. So to compute shader, can I push constants? Yes, I can. Woo! Incredible. So show me. So yeah, it looks like this. And then we have the struct and we set push constants. And it should be good. 128 bytes. Should be good enough. Okay. Let's do that. So. Push constants. I guess, well, let me go there. So we have, well, what do we need? Chunk cards, chunk size, block size. And I think that's all we need. What about NB blocks? Wait, that's actually the same, right? NB blocks and block. No, okay, no, that's completely different. I mean, technically, block size is like always 0, well, 1, I mean. But yeah. So we have this and we have NB blocks. Actually, we only need like Y and X and Y. But I guess we can send everything for now. I'm not gonna optimize. IVEC free. The not actually needed. Can be optimized. Then we have chunk coordinates, which should be this. Chunk size. What does that mean again? What is this? Default chunk size. So that's like the amount of blocks. NV cubes. Wait. Huh. Oh, NV cubes is in total. Oh, right. Right. Okay, yeah, I have to make the difference. I guess there's chunk size. We have this here. And technically we reuse it somewhere. Like NV blocks. Get block index. Yeah, that's a default versus. Okay, I get it. I get it. So it's like NV blocks in chunk. In the current one, and then you have the default. Right, okay. Defaults. NV blocks in chunk, basically. So that's like block size. Oh, no, not block size, but chunk size, I guess. Then we have the chunk coordinates, which is already good. And then we have the block size, which is just a vec3, which is nothing to think too much about. So let's say 4 times 3 times 4. We have 48 bytes. This is just nice. This is not a lot at all. So that should be good. Okay. Let's pack this like integrals with integrals. It shouldn't like change anything really, but yeah, we have this. I guess that's gonna be it. Wait. So this is layout push push constant std this, the uniform, I guess. Uniform push constants and push constants, I suppose. And when I want to use this, it's just push constants dot something. Okay, so let's try using this like here. Oh, that's gonna be big. I'm not sure I like this, but yeah, equal this times this, maybe. We have this and this. Okay, is it at least compiling? Even no, it's not. The shader is still not compiling. Oh, I still have to run it on like the rendering thread. I hate it. I hate it so much. But well, that's fine. Non-compute shaders can't be used in compute pipelines. Huh? What do you mean? Compute pipeline create. Non-compute shaders. Is that not a compute shader? It is. Huh? Okay, so I guess the problem is afterwards. The compute pipeline was set before attempting to draw. Oh, wait. So it's actually good now? Wait, it's actually fine. There's just this problem and I don't know why. Compute pipeline create. Boom. Shader. Um, hmm. Hmm. Google non-compute shaders can't be used in compute pipelines. No. I mean, that should already be good. Oh, fail to parse. Wait, you have this? L-value required vertices. Can't modify a read-only buffer. Oh, wait, you can actually see like compilation issues there. Wait, but it's not the case with this one. It's because I fucked it up, I think. But wait, this is actually so good. Oh my god. Can I re-import it the right way? I don't think I can. No. Yeah, I think I fucked up the ID, the text thing. Okay, so yeah, this is actually so good, my god. So useful. So L value required. Yeah, because I just set everything to read only. And I actually don't want that. I want write only for those ones. Re-imports. Vertices can't modify a read only. Huh, I mean, what's that? What? What? Cannot convert. Oh, it changed. Cannot convert from temp IP uint to layout write only. Huh. What? Huh? Can I just copy this? Is it when it's trying to assign? Wait, 110. Oh, so it's for this one and not this one. Wait, that's good, isn't it? It's int. Oh, is it because it's like uint? Oh, yeah, it is. Oh. Indices uint. Can I rerun this? Okay, let's run. One free this time. Oh, thanks for the follow. Hello, hello. Mr. Roulet, how are you? How are you? How are you? How are you? This is a uint. Those should be uints. Maybe. Let me do this just in case. And let's try. Wait, it really worked. There's no more error now. Huh. Okay. Well, actually there is. But now it's about... Okay, now it's not about the shader anymore. Okay, so the shader should be good. Great. The shader should be good. So now the size is different. Wait, storage buffer create. Data size is not equal to the size in bytes. Oh, because I'm... this is for this, right? Because I guess I have size of face times the size. Oh, yeah, because it's a span of... Oh, right. Yeah, it has to be times size of, well, the face. It's actually just the same. It's actually just this. In 32 byte size. Boo. Like NP bytes. Here we go. So that means I have to restart. Okay. I feel like I'm seeing myself in on the stream, and it looks like I'm just dying when I'm yawning. I just yawn way too much. It's contagious. Yeah, it's contagious. Hey, that was my plan all along. I'm gonna dominate the world. I'm gonna conquer the world through yawns. I'm gonna make everyone yawn, and they won't even be able to protect themselves during that time. It's like a zombie infection. I'm gonna infect everyone with my yawns. Okay, what about now? To the shadow. Yes, this is it. And that's like the only... Okay, maybe that's not the only problem. But yeah, this is good. So I need the push constants, which was part of, you know, what I wanted to have. So nope. Okay, let's go to here. We have... Wait, where is it? Push constants. You go there. Push constants. So it's like a struct. And it's gonna be vector 3. Wait. Vector 3i, I guess. Vector 3i. Vector 3i. And vector 3. Here we go. Oh, do I want this? No, I don't. Okay, and now I want to or the push constant. So we have the list, we have the data, and we have the size. So push constants, we have the data, and we have the size. And now I can set, shit, I need the chunk. I do need the chunk. Cube chunk and the space too, ideally. So cube chunk space. And we are gonna have all of this. Boop. Ooh. Dot. We do the equal, and this is gonna be equal to, so chunk cards, it's like chunk. Okay, I have to include. Core chunks, cube chunk. Spaces, a cube chunk space. So I have both. It's not removing them. So now we have get chunk cards. We have space defaults, chunk size. We have NB blocks in chunks, so chunk NB blocks. And then we have chunk size, like get, maybe it's in the space, block size, get block size. I think this is fine. I think this is good. So now I can just restart. Okay, and now if it works without any error, then that's just incredible. Because that means we would just have to retrieve the buffers and take, well, actually, there's gonna be a few problems with like the async. I need it to be in its own, or in the rendering thread. Wait, oh, right. Yeah, I mean, okay. Yeah, it's not gonna be good. Then we have, yeah, that's not gonna be good. We have this. We have this. Do little copy in process. And now in the cube chunk visual, we can just assign, well, send it here. We have the space, we have the chunk, and we have the faces, or like cube chunk maybe. Okay, this is perfect. This is perfect. I do want to forward declare, I think. Here we go. Let me forward declare it there actually. Boom. Here we go. Hey! What the hell are you doing? Is this a mod? It's not a mod. I might actually be able to show you what I'm doing if it's like at least not bugging. Which it might be. But okay, technically it shouldn't anymore. But I'm basically making a new game. So I'm saying Minecraft, but it's actually not Minecraft. It's just a voxel-based game. And yeah, and the goal is to have like funny geometry and stuff. So, oh, it's actually working. Look at this. So yeah, as you can see, I have like blocks, right? Like cubes. It's like Minecraft. I can dig. Textures are very ugly right now, but it's fine. That's not the priority. And the thing is that this is actually not like Minecraft. This is not flat, like infinitely flat. This is actually a donut. So it's like slowly getting generated. But it's actually going to make like a donut, like a circle, you can say. And like, for example, if I have some kind of tower here, you know, I can like make a bridge, for example. And you can see that with time, like as I build the bridge is actually going to bend, right? It's not flat anymore, like if you look in the distance, right? And if you continue to walk this way, so I have some performance issues, but the goal is to fix that. That's what we're trying to do right now. And if you walk this way, you can see that I'm actually just looping. It's like what Notch made for the first Minecraft versions. Just Notch created its own game engine. What's the end goal of this project? The goal is to make a game. Oh, it's a donut. Here we go. So the goal is to have basically a very flexible voxel engine that can support different type of voxels. So maybe you can have like cubes, right? Like a planet with cubes, but also a planet with like octagons or something like that, or like non-Euclidean planets, like planets with like impossible geometries. And yeah, you're basically going to have multiple planets, like this donut, for example. That is one. And you know, each planet is going to be special in its own way. And you're going to have like a survival mode. You know, it's going to be like a survival sandbox kind of game, like Minecraft in a way. You're going to have like some dungeons. I was thinking about those, some enemies, and I guess also something I want that I definitely want to work on is I want vehicles in my game. Like for example, I want, you know, a car, for example, but I also want like a boat, like a plane, and also like spaceships. And you know, be able to have like spaceship battles, for example, that might be sick. Like vehicles that are made with voxels. So that means you can build on your vehicles and you can destroy them. And like in space, like if you have like a war against like other people, like in multiplayer, then you know you can destroy each other's spaceship, that kind of thing. Yeah, Obsidian Xing, welcome. And yeah, you also want like basically giant creatures, like a giant turtle that you can build on. Like you can have a village on a turtle. Like I'm thinking about Drawn to Life turtle. I'm thinking about this turtle. You have this giant turtle and you can have like your village on top of it. And I basically want this kind of thing with like giant creatures that, you know, you can also like build something upon or like inside. Like if you have like a giant whale, for example, you can get inside its body and just like explore, like, you know, maybe it might be its own dungeon because like inside the whale can be dangerous, right? You have like acid and stuff. So maybe you might want to explore and try to find like hidden treasures, that kind of stuff. I see the idea. I think it's very exciting. What is the next step for this? So basically right now, I'm trying to optimize things a little because it's, well, actually it's like very fast, as you can see now that it finished generated. I have like some collisions too. Like this, boom. But I guess I want to stabilize things a little bit. Right now, I'm moving computations on the GPU to make things a lot faster, or like more precisely, the generation of chunks faster. So that would be sick. After that, I want to finish my collisions because right now they're working, but actually only in one direction. Like if I go there, it's not working. So I want to fix that. And after that, I want to start implementing like work more on the generation, like add the forest, add maybe the first dungeon, add some gameplay elements like enemies, like the player, add gravity, of course, and yeah, start making like some gameplay things. That would be the idea. And after adding like a few enemies and maybe like some kind of dungeon or like a nice beginning for it, then I also want to add multiplayer, and that's why I can play with my friends, and I can have like even Among Us in this game, for example. I want basically the goal is for this engine, you could say, to be some kind of sandbox for me where I make like multiple kind of games, but I do want to make like a main game which is like survival based with like a dungeon, well a dungeon, ruins, you could say, and like some kind of ecosystem um, with like the forest and like the enemies, that kind of stuff. So for now, I'm gonna only have one planet, but that's like the beginning. So after I have like some, basically, I'm trying to set my priorities correctly. And for example, right now, the rendering is like really bad, right? There's no shadow because I'm making my own render pipeline. So I would have to re-implement shadows myself. And this is afterwards. I want to work on the gameplay first. Because I think, there's like a lot of voxel engines that lose themselves in always optimizing more, adding more things, making things maybe a bit more pretty, that kind of stuff. But we need a game. I want a game. How long do this project... How long is this project in the making? And you're the only one that develops the game? Yeah, I'm the only one. And I actually took a break for like 1 week maybe, because I had like an exam, like a Japanese exam, a Japanese test. But it's been like, I was gonna say a month, maybe a bit more, but not really if you remove like my 1 week of absence. What is that? Okay. So yeah, if you look at this, my YouTube channel, and I started roguelike. So done it 1 month ago. I'm not full-time on it either, right? It's not my full-time job, which makes sense. But yeah, it's been 1 month. I basically spent... I mean, it doesn't look like I have much, I guess, but I spent a lot of time building the engine. Like, I guess working a bit on the collisions and the rendering, because I have my custom render pipeline, for example. But also, okay, I'm gonna show you something incredible. So you know how, let's say you have a donut, right? So your donut looks like, I don't know how to make a donut. It looks like this, okay? You know what? This is a donut, right? So let's get a slice of it. If you take a slice and you have all the cubes on top of each other, then that means it's going to look like this, right? Because you have cubes as a surface. And you notice that the problem is that your cubes are supposed to become smaller and smaller the more you dig down, right? And that sucks. And that's also something I spent a bit of time on, is that when you dig, right, okay, my collisions, I have to update them. I still have to work on my collisions a bit. But if I remove the colliders, okay, I have a few errors, that's fine. If I remove this and I dig, you're going to notice that it's actually always going to be cubes. Even though, logically, it's not supposed to be cubes, right? Like, it's supposed to become smaller and smaller, right? So, like, it's supposed to be distorted into rectangles. But we have, like, squares everywhere, right? So it's like a very nice thing I worked on. It's like some distortion I added to the game to make it like better underground, because otherwise, like, rectangles, like, it would just be really bad. And that also means funny things like let's say you have your donut like this. That also means that technically, let me increase yeah. That means that this distance, like if you walk around the donuts, it's actually the same distance as this. It's the same distance. I know it doesn't look like it, but it's actually the same distance. Which is pretty sick. Which is pretty sick, isn't it? Because you have the same amount of cubes outside as you have inside. And locally, it's always going to be cubes. It's always going to look like cubes. So in the end, it's like the same distance. And yeah, I was still generating a little bit there. I mean, I can optimize the generation, but yeah. What is your opinion about Godot Engine? What are the pros and the cons? I mean, the cons are definitely that it's like not Unreal. Like, you have a lot less features, but it's like not a problem if you're making a lot of things yourself, like I'm doing right now, because it's like a voxel engine, right? That I'm making. And what? And the pros is I really like how flexible it is and how lightweight it is. And it's open source, right? And it's like free. Like, it's like the best selling argument. It's free, 100% free. And other than that, something I don't like is vectors, but I can understand why they did it. Like, I don't like how they implement vectors in C++, but that's like a detail. I feel like in the engine, they have... Well, okay, in a lot of places, they prefer safety rather than performance. So you're going to be sure that it's not going to crash. But in my case, I do want some performance. So it's like not taking a lot of performance though. Like right now, right now it's like very, very fast, right? But if it's lagging during generation, it's actually my fault. So it's like not even something that really impacts performance in a big way. So that's not like a big problem. I would say that's it. I mean, I do think it has like I mean, just the fact that it's free, open source, and so lightweight and so modular. Yeah, it's like very modular too. Like if you look inside the engine, you can see that you have it's like divided in a lot of different modules, which is like really great. And I like that a lot. It's like clean. The architecture is clean. Features are split. And yeah, it's pretty easy to understand. It's pretty straightforward. Oh, do you generate blocks? Do you generate them like in Minecraft? Chunks? Or you're doing in another way, or not even at all? Just blocks appearing. Then I recommend chunks and maximum amount of chunks. Right now I'm using chunks. Right now I have chunks, but I want different implementations for the chunks in the end. For performance before other heavy elements are implemented. Well, basically right now I have chunks that are, arrays, like one chunk is an array of blocks, but I want to provide multiple chunk implementations about, the data structure, so I can store chunks in different ways. And like, for example, if I have a chunk that is empty, instead of storing like all the blocks of air, I'm just not going to store anything, and I'm just going to have like an empty boolean, maybe something like that, or like as in an implementation. Or like, for example, if I have chunks that are solid on all different faces, even if they have like a cage inside, for example, like a hole, if it's not visible from the outside, like if it's fields, then it's going to not generate like the visuals for what's inside. It's not gonna generate the faces inside. So, like some kind of optimizations like this. Like, for example, for chunks that are as a surface, there's going to be like a maximum eighth. So I don't have to store the cubes above that because it's gonna be air. So, trying to optimize things in some ways. But for now, I'm not optimizing what I don't have to. I don't think I'm gonna have to implement all of this. I really want to focus on, speed running things a little, focusing on the basics, like rendering, making sure it doesn't freeze, collisions, and then the gameplay. I would say that's my priority. And after I have like some gameplay, I want to work a bit more on rendering because it sucks right now. So like add things like ambient occlusion, shadows, ray marching, or like fog, that kind of stuff. For performance before, never mind. Have you used game engines? If so, which one do you like best? Yeah, I mean, basically I started with Unreal Engine. Professionally, I've used Unity too. I mean, I've used Unity and Unreal professionally. Right now, it's been like almost two years maybe since I started using Godot, like 1 year and a half. So I'm like pretty good on it, I would say. Like, well, good. I would say I know like a bit about it. And I'm basically like my job is I'm an engine developer. So like a game engine developer. So, I worked on multiple custom engines. And I would say, which one do you like the best? I mean, Godot is definitely among my favorite ones. I mean, I'm basically only using Godot right now, personally. I could use Unreal. I really don't like Unity. Because to me, Unity is like for mobile. But if you want something lightweight for mobile, then why not just use Godot that is like completely free and open source? I mean, you do have like maybe less support for from the community. I was thinking, for example, about anime shaders, that kind of stuff, like Genshin Impact, right? But you actually have a lot of people that work on Godot too now. You have like Dialogic, that is like the best dialogue plugin I've ever seen on like any engine. And yeah, I guess like if you want a leaderboard, for example, you have Silent Wolf that provides some for free for Godot. So you have like a lot of support. I think a lot of people are going on Godot. Unity is like basically falling apart right now. You have, I think they fired a lot of people recently, so I wouldn't go on Unity. And like Unreal is definitely something I might use if I want to make like a triple A game. Like if I had like a company, but to me like Unreal is like the engine, like it's the mastodon. It's like the engine you use when you have like a big team and that you want to split tasks. Like if you have artists, they can work in the shaders like by themselves. If you have game designers, they can do some stuff in Blueprints. If you have programmers, then they make tools in C++. If you have sound designers, then they can do things in Metasound, right? Like everyone has its own part of the engine, which is like really great. But at the same time, if you're like a solo dev, it's like a lot, and it's fine. Like you can implement things if you're a solo dev. But I mean, Unreal Engine is like, I mean, you have to pay first, I guess, if you win like a lot of money, I guess. Um, I guess that's not that much of a problem actually. But it's also not very lightweight. And I do like how Godot is like very lightweight. And in my case, I'm making my own voxel game, right? With like a lot of custom things. And like, for example, in Unreal Engine, the rendering pipeline is like very complicated because you have a default one, so that materials are compatible with with it. And if you want a custom rendering pipeline, it's like so horrible to make. So I guess that's why I'm using Godot right now and not Unreal for this game, because I want to make like a lot of custom things, right? Like just the distortion for my donut, right? Like that would be like so complicated to make in Unreal. Like I would have to look at the C++ code a lot. I would have to debug. I would have to compile. It's gonna take like 1,000 years to compile because it's C++ and like Unreal is big. So yeah, I like Godot for that. Have you worked on other games too? And how many? And you went to school to learn how to code? And what type of code you can code? For example, you can code Python, C#. Okay, so I know. So basically, after high school, I've been to a game dev school in the game programming courses, where I've learned like a lot of engine kind of things, I guess. And I guess about what languages I know like Python, C Sharp, C, C++, Java. I mean, technically, then I'm going to start talking about the languages I know a bit less about, that I'm definitely not a pro about, but that I've used. I guess I've used a bit of HTML, CSS, well, technically a bit of PHP, I mean, JavaScript, okay. A bit of Ruby, but it sucks. I guess I see the syntax of Lua. What else? I mean, I know Blueprints, of course, because Unreal. I mean GDScript, of course, because I'm coding in GDScript 2 in Godot. I mean, I don't know. Thanks for sharing. You're welcome. And yeah, I might not remember everything. I'm definitely not a pro in all of those. I mean, I guess like I did a bit of CMake, if you consider that to be a language. I mean, I guess HTML, CSS are not really languages either, right? But Yeah, and yeah, about other games I made. I guess I have personal games, and I also have, games I worked on professionally. Sadly, I can't show anything I worked on professionally because NDA and stuff. But like I guess I did a few things. Like I made my custom engine. I made my own rasterizer. I made a Metroidvania. Well, I mean, this is like pretty old though. If you go on my itch, you have like other games I made, right? That are like a lot smaller in scope. But yeah, you have those. You have like a rhythm game, you have like deck builder roguelike, you can say. You have a Metroidvania, you have like some kind of top-down RPG, you have some kind of Paper Please kind of game. You have a platformer. Well, this one is Paper Please actually. And different things. But yeah, if you have any questions, feel free. I guess my best the best game I can show is this one. Let me stop the music because I have to show you the full experience. The full trailer. Boom. Okay, are you ready? Are you ready, people? I'm just gonna close this. Well, I actually have to check like the different errors I have, but I guess it can wait. Oh, that's like a lot. Okay. Here we go. Are you ready? Let's go. It's my game.
In some parts of the world, people believe that us gods can walk amongst them. But with their prayers, they might call upon the wrong ones.
I hope the volume is fine. Should be good.
Welcome, gods! If you want to ascend as a superior god, you must eliminate the target. Use these mortal souls as you see fit. I need to hurry. Blend in the crowd of the Pultok market.
You had French text. That's fine.
But beware, the city guards are watching you. Gain power with the artifacts of Is.
It belongs to me.
Defeat the greater evil and prove yourself in the trial of Sicaria.
Oh, this game was so sick. This game was so good. Like, I loved playing it. Like, we played... It was basically a multiplayer game. And it was basically... The goal was to obtain artifacts to kill, like, a big AI guy. But it was multiplayer, and you had to be the first to kill it. But at the same time... basically, players can... Well, you have a lot of AIs walking around that are like, that are not going to attack you or anything. Well, you have a few big ones that are going to attack you, but the villagers are not going to attack you. But the different players can act like villagers, and because they have like the appearance of villagers. So they can act like villagers, and it's like a bit like Among Us, right? Like you have some imposters that might want to kill you, like the other players, to take your artifacts and kill the big guy to win. And it was like so good, man. You could like change characters to like change villagers because you basically control a villager, but you can switch to a different villager. So, you can like suddenly teleport next to another player and just kill it and get the items for yourself. But then you realize that there was another player that just killing you right after that. And it was incredible, man. I really want to play it again. Maybe I might organize like some games in the future. But yeah. And what are the problems? Push constants. Supply is 48. Oh no. 64. 48. So let's try to compute this. 64 instead of, wait, 64, 48. Supplied, okay, 64. So this is 4 times 3. So a float times 3, so 12, times 4. So it's like 48 in total. But it asks me to send 64. It's a bit of a shame that it's just not. I guess I need some padding. Okay, I'm gonna pad if that's what I need. Mm-mm. Let me think. Can I just align? Well, I mean, even if I align this, C++, like C, align data numbers, align strict numbers. Attributes packed. That's not really what I want. Forcing stricter alignment. Align us, that's what I want. So it's align us 16. Boom. And here we go. Now it should be good. It's cool, thanks. Yeah, I mean, once again, if you have like any question, feel free to ask, like whether it's about programming, whether it's about game dev, whether it's about whatever you want. I make a few documents about game dev if you want. Like about game design more specifically. Like for example, how to make like a good roguelike game, or like what are the main elements of it. Like this, for example. It's like publicly available. Like the different pillars, and like the different things you might want to implement out of that. Like builders too, you have like a few things. And let me bring back the music. Wait. Yeah, that's fine. Okay, let's trade again. Oh, it's only 11 p.m. Okay. Can't create a buffer. Okay, this is good. So the push constants thing is fixed, but now we just have this process. I just don't know what this is about. Buffer create. I still don't know what this is about. Can't create. Well, I mean, it has to be about what I just added, right? Like, I mean, I guess if there is like no faces, if there are no faces, then I should not call this. That makes sense. So I get the faces. And then I do a bunch of things. And this is bad. Is empty, I return. I should actually return before that. Wait, what? What is empty? Triangle in... Oh, right. Yeah, okay, let's just have... If this is not empty, I do this. And then it's basically just a loop around the faces, so that's safe already. Okay, so that should be good. I'm just gonna restart, but I think that should be like the... What's the biggest problem? No, it should not... I should not have any problem anymore. Well, I mean, the only problem is I have... Well, actually, that's the multi-threading issue with like the compositor. I need to use the compositor to run it on the right thread, and then I have to get it back. Okay, let's go. There's no problem. There's no error. So the shader is now running fine. The compute shader is running fine. Oh, this is so good. So we have the compute shader. Now we just need to... I mean, there's not even like a problem about the different threads now that I think about it. Okay. So can I maybe just get it? Just get the vertices and stuff. On vertices, read back. Yeah, you have to wait for the end of the... I was gonna say frame. Maybe not frame, but... I mean, I guess I want to add the different tasks to a queue. Process. I'm not sure about all of that. Maybe I can have item, which is going to have like all of those IDs. So I can run it on the right thread, and then I have, in any case, I'm gonna have a callback for when it's finished. Something like that. Oh, actually, I should be able to bind things. Well, maybe not. Vertices or ID. Yeah, I don't like how many different IDs I have, how many buffers, because that means I'm gonna need like a callback for all of those, for each one of them. At this rate. Because I can't... I could make this like a resource or something like that, but I don't really want to. So on vertices, Read back. Yeah, I don't like that at all. Okay, for now I'm just gonna have this, okay? So this is gonna be fine. I'm gonna have maybe this here, right? Maybe this. So create buffers. Wait, what? No, not in create buffers. In process. Oh, actually, if I have... Oh, wait, that's actually good. If I have the chunk, that means cube chunk. Oh, it's not even the cube chunk visual. I mean, I do want the visual though. But then what about the implementation? What if I want to change the implementations? Yeah, okay, let's make this independent of... Let's have this for now. So we have the callback. We want to bind it here. And like, let me actually copy this. So we have the callback. Okay. That means I'm gonna remove this. Boo. And instead, this is going to go in the chunk visual here. Right there. So I guess it's like callback vertices, well, on vertices generated equal this thing. It is not working. On vertices readback. Yeah, I guess I have to create this. Like here, for example. Then I have this. In the end, boo. I read back the vertices. Okay. That looks good. Kind of. And what do I want to do? Vertices. I guess I want to push back. So like it's a packed byte array. Something like this. That size. But I divide by the size of vector 3. And then this is going to... We're gonna get a pointer to this. And vertices data, we could say. So it's gonna be something like this. We can cast. And now, so the size should be const nb vertices. And this one is size divided by Well, divided by, yeah, okay, by this, right? I just had it there. So in the vertices we resize, and then for all of this, we just assign. So it's like a debugging version. It's like to debug. Like in the end, we shouldn't have all of this. We shouldn't retrieve things on the CPU because it's like kind of slow too, I guess. But yeah. So vertices I equal vertices data I. Here we go. Here we don't go. Huh? Pax vector 3. Oh, it's a set. Right. That's fine. I can do that. Here we go. So now we should be able to set vertices like this. I don't know how much more optimized it is, but it shouldn't be more optimized. It should be like slower actually. But it's like for debugging purposes, we go like slowly from one place to another. Mesh storage. Replaced by this. Yeah, I mean, this is like getting a bit obsolete too. Yeah. Yeah, let's just remove. Huh? Right. I mean, I guess colors, maybe one day. I mean, I'm gonna keep the colors. Then we have all of this that we might want to actually remove. Because now it's working without this. Push normal. Custom 0. I mean, technically I can remove this because I have this here. On vertices, wait, do I not have this? Wait, that's the pipeline. Here we go. Okay. Okay. So it should call the function with like the vertices. I'm actually not sure what it's supposed to be. Well, I mean, I'm not sure how I mean, the best way to debug vertices and see if they're good or not is if we replace them. So like I have all of this, for example. Rebuild mesh, and instead of doing this and the rest of it, I'm gonna split it into a different function. Create, AABV, okay. Yeah. So I'm gonna try rebuild mesh and have like a rebuild mesh 2 or something like that. So like from here. Actually, okay, before making drastic changes, I want to push this. I want to save my work because I feel like I might break some things. Boo. So this is gonna be 2-7, 2-8 maybe. Yeah, should be fine. No, it's not. Wait, is it? Created vertex generator pipeline. Yeah, I guess that's fine. Log 28. I guess it's like a whip. And it is about vertex generator pipeline using compute shader to generate vertices added and running without errors, but not doing anything. Well, but not being used, I guess. Should be fine. I have to connect to GitHub. Huh? Send SMS, I guess. Oh, like, oh, I guess, never mind. Can I use authenticator? Okay. Sorry about this. Okay, here we go. We have one. And the other one should be there. I'm just gonna push it just in case. Because I guess I have the shader, which is like a pretty big thing. And I should also push this. Also this. And what's it? Well, export, never mind. Taurus, main. I want to push main. Because I just added the path to the compute shader, right? Wait, shader. Wait, what did I do with this one? Oh, never mind, I know. Yeah, it's a comment. So that should be fine. What was it? What's this? Vertex generator pipeline added. Wow. In my case, it's vertex gen compute shader added. Generating vertices, running without errors, but not being used. I guess that's fine. Okay, now we can have a bit more fun. Now we're gonna break a lot of things. So that was about readback, splitting to another function. Okay. So we clear, we have a lot of things. Okay. I want to split this. One, two, three. Something like this, and now I need the faces. So That's gonna be a bit complicated. Technically, I guess I can have those there. Places. Can I? No. Oh, wait, I can. It's not gonna be good. Let me add it in the header file, just in case. So, what is it? Faces. But now I have faces here too, right? So technically I can have... Is that gonna be a copy? I mean, technically I can just move, even. I'm just gonna comment this for now. And no, there's no go to move, I think, so just std move is fine. Okay, I have the different faces. If it's empty, then too bad. And this is undefined. Right. Because of this. Wait, profile zone. Oh, there. Yeah, it's like very bad. That's fine. So cube chunk, nah. I guess I'm gonna just copy a few things. Cube chunk. Well, at the top. Here we go. I need face. Wait. Face, chunk size. Okay. And RS, scenario, and NV blocks. RS is there. And the scenario is all we need after this. So where is the scenario? It's there. Here we go. So I can move it there. Well, basically I just copied everything, right? That's basically what I did. But that aside, well, I mean, technically, oh my god. Technically, I could just remove everything. You know what? Maybe that's the thing to do. I'm just gonna copy this. And keep it there. But if I just remove... And... So we have all of this, right? Okay. So now... What I want is this is gonna be 2. And I'm gonna have another one. This is going to be the normal one. That is just going to have this. Boop. Space visual. Huh? Right. That's fine. So space visual, cube chunk. Like there. I don't even need this. Okay, and we have the rebuild, and this is it, and this is it. I guess I need a callback though. Compute. Okay, yeah, compute the visible faces. And I guess I just want this afterwards. Okay. So that means I can remove this. I can remove this too. This is gonna be rebuild mesh too. On vertices, and then we have this. There. So vertices should be fine, technically. And that means I can remove this. I can remove this. I can remove this. I can remove this. And then we have the rest. And I do want to update the vertices and stuff afterwards. Okay. Okay, is it going to be good? That's the moment of truth. Right here. Am I going to be able to read it back what I want? Is it going to work? Even if it's like a bit slower. Am I going to have the right vertices? Is it going to display things correctly? If yes, that means the compute shader is working correctly in every way possible. And then we just have to reuse the buffer for our rendering, which I'm not sure how to do right now, but you know, we might be able to make it work somehow. Oh, that's gonna be so bad. Yeah, that's gonna be a pain to make it work afterwards. I really don't want to take a look at it, but I mean we have to. Okay. 3, 2, 1. Let's go. Don't crash. It's not crashing. Text is now. Huh? Okay, it just crashed, I think. Yeah, now it crashes. A few frames in. So it does crash. It does crash. Let me check where it's actually used. But I think it might be because it's like on the wrong thread. But connect when I set and I mean okay, this looks fine. Okay, here. Well, I mean it's the destroy and here. And we return. So we rebuild. Wait, what? We rebuild it directly? Instantiate chunk visual. Huh? I mean, I guess I'm not even using it here, right? I'm just discarding it. Is loaded. Yeah, I mean, it should be good, right? Probably. And text is null. What do you mean by that? Texture get data async. Parameter text is null. Rendering device get data async. I mean, yeah, this is basically where is it? Where is it? There. This texture is null. What do you mean? Create buffers. Vertices or ID, right? It's like supposed to be something. It is. Maybe it's. I was gonna say maybe it's not because. You know what? Let's put a breakpoint. Let's not think too much about it. Let's just run the game. And see if it's actually null or not. I don't think it is, because if it was, there wouldn't be, you know, like, well, there would be like errors in JavaScript, but there wasn't really any error. Okay, so here we go. So this is valid, but data is null. Wait, what? Method. Object is something. Method is null. Oh. Oh, okay, this is why. I have to register it. I have to register it here. Okay, okay, if that's just this, then it's not that much of a deal. Of a big deal. Boom. And buffer, I guess. I'm gonna try on texture with back. Boo, if I look at this at the beginning. Wait, I actually don't even have this. Never mind. Never mind. Oh! Wait. On vertices read back. Ah! Ah! So this is valid, but this is null. Oh, the data is null. Maybe that's, wait, method though. Object is fine. Custom method pointer. Yeah, maybe this is fine. Let's continue. I mean, this is valid for now. Oh no, there's a crash. Interlocked compare exchange. Oh, atomic. Wait, that's a multi-threading issue. Lock, spin lock. Oh, mesh storage. There will never be more than at mesh 3 or 4 versions. Huh? Wait. Will there? What does that mean, huh? I mean, yeah, right now there's basically a problem with the spin lock. So this one. So yeah, it's a multi-threading issue. And it's because of create vertex. So it's a crash in my rendering pipeline. my render pipeline, my pickup render pipeline. That shouldn't really happen. Well, actually, it creates vertex attributes. Wait a second. Well, actually, it is a problem. Because... Oh, wait a second. Mesh or ID. This looks valid. What about the vertices? Do I have... Can I just generate 2 times? Just to make sure. Yeah, that's... Okay, I'm gonna do something very not performant at all. But sometimes, you know, we need that. Rebuild mesh. So I'm just going to call rebuild mesh 2 at the end. Or maybe at the beginning even. Add vertices. Oh my god. This is gonna be true. So we are gonna have this. Well, here. Then we are gonna have false here. Oh, this is so bad. But that's fine. That's all part of the plan. Boom. So yeah, now I just need to... If we add, I do this. Same there. If we add, I uncomment. Technically, I guess I can do this. Then I have this. And that should be all for the vertices. That should be it. So basically I'm creating the visual a first time with the right vertices and stuff like before. And then when I'm reading back the texture, I'm regenerating the whole mesh with the new vertices though. With the new vertices. And yeah, I mean, I guess that's it. So the goal is now the pickup render pipeline should not crash anymore. Maybe. Okay, it's still crashing. So this is definitely because it's like the wrong thread, I think. But that's like a mutex though. That's what's crazy. So wait, what happens if I just do... If I just do this, is it gonna be good? Is there going to be any problem? I don't think there's gonna be any problem, because the real problem is that I'm not using the compositor. Is that I'm not processing the vertices on the right thread. It's gonna be midnight soon. Hides class member. Wait. Does it? Okay, so wait, there is still a crash. Wait a second. That's bad. So faces. It's because there is no face. Wait, what? Wait, what? I mean, I guess I can technically just remove this, right? Yeah, I guess. Okay. Okay, my bad. I don't need this. I'm just using the faces out of the header file of the class. I'm writing into the faces of the class. Okay, so now we shouldn't crash anymore, and then we can try our thing again. Just by uncommenting this. Okay, so now it doesn't crash. Good. So I wanna restart, but now I'm gonna uncomment this. So I'm gonna have the read back, and I'm gonna see if it's like working or not. If like the vertices are the same. I mean, actually, I could just compare instead of assigning and stuff. I could just compare if like the two arrays are the same. Yeah, you could just do that. But let's see in action. And it seems to be good. And it is good. So, okay, now I want to make sure this is fine. And for that, I'm just going to remove this. And that's it. And now the only place calling rebuild mesh 2 is the callback, where I tell the function to not add vertices. Like this is false. And if it's false, it's just not adding vertices. So if this works, that proves the compute shader is just working really well. I mean, there's no reason it doesn't work, right? But yeah, I just want to ensure. Okay, never mind, it doesn't work. This is because of the little delay at the beginning. Okay. Let me think. I kind of know why this is doing this, I think. But let's just do this. Let's put a breakpoint, and I guess we can compare. But actually, let's just yeah, let's just do something simple. We can just have an assert, like a crash condition. If this is not equal to this around, right? So near, like near vector. Wait. Go to vector 3. C++ nearly equal. Maybe it's like from the math library. Is equal approx. Right. So this is equal approx. If it's approximately equal to this, then it's fine. I'm just gonna put a breakpoint for the fun. For the fun of it. I mean, yeah, I guess the problem with the render pipeline is that it's trying to get the vertices and stuff. Okay. Wait, it's not getting called. On vertices, read back. Wait, this is actually never getting called. Huh? Sorry? It's actually just not working. It's actually just never getting called. That's why it wasn't lagging either earlier. It's because it's just never getting called. Wait. What about here? So yeah, this is getting called. If I go in, this is definitely going there. This is valid. I mean, this is null. I'm just not sure if like the function is valid. That's the problem. But I mean, it should be, right? There's no reason it isn't. Get data sync layer 0. Texture usage can copy. Oh, yeah. Okay. Yeah, I need oh, I forgot about that. I need to set the flags. Yeah, I'm setting the usage flags there. Output texture. Okay. This is gonna be good. So vertex generator pipeline. I have all of those things. And right. There. Vertices. So I guess it's null. Then we have the usage. But it's just not. It just doesn't want my null PTR. 0. Wait, what? What do you want? Oh, a span. Wait, that's... Huh? By default, what is it? Well, I guess it's just this. Yeah, that's fine. And usage. Ah! So let's check the usage. Because we want to copy that back on the creation bits and p usage. Wait, what is that? As a storage, device, or dynamic persistence. Okay, and this is Storage buffer usage dispatch indirect. I'm not sure. Let me ask my friend ChatGPT. Storage buffer create. Well, if I want to read back my buffer on the CPU using texture gets data async, do I need to add a flag to this? Which one? No, don't have a usage flag. This differs from textures. There is no equivalent CPU readable or copy source flag that you need to set. You can always do that. Buffer get data. What? Can I? Or the asynchronous version? Yeah, this is the one I'm doing. The engine handles things. White textures have flags, different memory layouts. Buffers are much simpler, but it already knows that it's buffers. Can stage a copy for readback. Do I need to submit? No, I don't, right? Maybe I... I'm using this. Why is my function never called? Yeah, I haven't called submit, but I think it's because I'm in the wrong thread. Most common issue. Are you using the main one? The callback is processed by the render thread. If you're using a local is the callable still valid? Good question. I think it's fine, right? Yeah. Is the buffer still alive? Still alive? I'm not freeing it. Is your callback signature correct? It should be. Are you calling it every frame? Oh no. I mean, I definitely should I call submit if I'm on the main thread. The answer is no. Yeah, I'm not inside. Yeah, I mean, I guess I'm gonna have to do that. Shit. Yeah. Okay, I'm gonna have to... Shit. Let's go inside the pickup render pipeline. So I guess I want to create a compositor. Do I? Wait, don't you... Well, not really though, right? I just want to add a compositor effect. And now this is gonna be... Yeah. What is... Well, okay. Compositor or ID. Set compositor effects. And then I set it. Ah, I really don't want to do it tonight. But at the same time, I feel like I kind of have to. Compositor or ID. Compositor, set compositor effects. I'm just gonna wait, rendering server. It's just RS, right? Yeah, why am I doing this? RS. It's a bit better now. So now it's RS get compo. Well, get wait, composer effect. Get effects. I guess I don't have this actually. IDs typed. Pushback or IDs. Converting from a typed array to a vector. They do the same shit. Yeah, that's why I don't like Godot. It's like compositor storage. Okay. Mm-mm-mm. Yeah, that's just the set effects, but never the get. Wait. I still need this. How can I specify it like only for one frame though? How can I add it? Well, how can I run this on the on Godot's render thread? Only one. Colon render. Wait, you can do that? Wait, you can do that? The schedules. Wait. Oh, this is. Oh, this is crazy. Oh, I don't need the compositor. One render thread task. Oh wait, I love that. What? Yeah, I mean, makes sense. If you need a result back on the main thread, avoid calling scene tree methods directly from the render thread. If you're generating many chunks, yeah, I mean, I'm definitely going to try this. Put on render thread. Yeah, this is perfect. Yeah, because I don't want like a compositor or something like that. So I guess I don't need this. Actually. And then we have the process. I mean, I guess faces is fine. Shrunken space, nothing should like change memory. The callback should be. I mean, I guess it's not going to be fine actually. It should be fine if we bind it. So let's say we have this rebuild mesh. We have process. And this one is going to be rendering error. Get single done. It's like RS. I don't have it here. What I mean, RS. Call on render thread. Here we go. And we have a collabel. We have a collabel. And this collabel might be one of this. Puts lambda in collabel. Can I do that? Oh, I can't. Okay. I basically want to, like, let's just do a request vertex 10. So we have like this. I guess we have this. Boo. No, I moved that right there. And it's good. And it's good. And now I just call this on the render thread. Yep. So this is good. This is all on the render thread. And that means I can remove this. And that means that all of this is fine. Is it going to be good now? Am I going to have my breakpoints break? Callback is fine, faces is fine, those are fine, memory is correct. I mean, this should be perfect. If this doesn't work, I don't know what the problem is. Yeah, I didn't think it was like that easy to run the something on the render thread. I mean, that makes sense. That is not that bad, but yeah. Okay. Okay. Text is now. What do you mean text is now? Rendering device, text is now. Process. Boom. What do you mean text is now? Okay, it's the end. So this is now. From P texture. Texture owner. Wait, texture owner. Huh? How is it? Huh? What is this? Texture and true. Oh, I had this problem before, but I don't remember what, like how I solved it. Let me GPT it. Rendering device. When I call this, I'm calling this texture. Well, texture is not found in texture owner. Why? What is this about? The RID I'm passing is not a texture owned by that rendering device. Is it because I'm creating... No, it's like on the same thread. Right? RD. Get singleton. Storage buffer create. What? Get singleton. I mean, that should be fine. Oh, is it because the buffer is not... is requested? Well, never mind. You're using the wrong one. The RID isn't actually a texture. Oh! Oh! It's not a texture, indeed. Buffer. Oh, right. Get data, I think. Oh. Then we have this, we have offset, and we have size. Wait. Oh, RID. Oh, right. Okay. I mean, at least now we know it's on the right thread, which is good. Okay, okay. That's good. Please, vertices, be right, be good. I mean, the compute shader is running properly. I just don't know how I'm going to replace my vertex buffer by those new buffers. But you know, we might just see how it goes. Okay, here we go. So if I check this, 397887. And this is bullshit. Shit. I mean, I is 0 in any case. Oh, no, never mind. That makes sense. It's because of the transformation. It's because it's transformed. So yeah, it's normal that it's going to crash. The question is, what if it's not transformed? Like there. Well, I mean, yeah, I mean, I don't like the AABB. I mean, the AABB is going to F me. But, like this. Because of this. I mean, at least it should not crash, right? Like, the data should be the same. And that should be good enough for me. Well, good enough. Not really, but yeah. Okay, okay. Read back, read back. So this is 0, and this is... Wait, actually. So 0 and 0. A. Okay, it does crash at 1. 0, 1, 0. And this is... What is this? 0, 0, 1. I mean, it's like pretty much the same. Come on. I mean, I guess it's a bit different. Okay, but this is like a problem of just not copying the right way. So this is not that big of a deal. So not this, but this. So X, Y, Z face index. Wait, is it actually good? Where's the face? Wait, I actually don't even know where the face is. Oh, it's there. Boom. Wait. Boom. X, Y, Z face index. It should technically be good. I mean, I can't do that just in case because I think like at one point it was like inverting things, but I'm just gonna run again. Oh wait, that's actually the opposite, isn't it? Wait a second. Because the first one... Wait. Yeah. Wait, if I want to unpack... I'm just gonna copy this. If I want to unpack in the shader from an int, what is it? Yeah, I think I have to start with face index actually. X, actually no. Wait. Yeah, I mean, if X is there, doesn't that mean that I have to move it first? Unpacking. Couldn't I unpack face index first? And do 24 on X instead? Little endian. Is it? Wait, so X is there. Oh, because FF is right. Yeah, okay, it's fine if... I'm not sure. One, two, three. Okay, I guess this is fine. Okay. What's the problem? If it's not this. Yeah. I mean, I think it's like one of the arrays, maybe. It feels like that might be the case. Boom. Boom, bang. Okay, so we have a lot of things. So we're only looking at the vertices, right? We're only comparing the vertices. So if we compare, we have ID times 4. So we have the face times 4 because of this. So it's like ID. And we do a plus I, which is vertex index, which is correct. We plus 1 at first. So then we have the position, which is face XYZ. And that's what I have to. So I mean, this is supposed to be 0 anyways. So 0 plus the chunk coordinates, which should be like 0, 0. No. And then we have this. I think this is a problem. Yeah, this is definitely the problem. That makes sense. So local vertex indices. Okay. Let's go here. We have local vertex indices 0 to 3, 4, 7, 4, 5, 6, 7. Okay. So what do? We first take I into this. Wait, 4. Wait a second. Yeah, it's an array of arrays of 4. So we first face index 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Face 2 vertices. Well, yeah. So we get the local vertex indices from this, which should be good. Then we I. That's what I do. I put I inside. And then I have the face vertex to offset. Which is a vec4. And const vertices is this. 0, 0. So 1, 0, 1. Yeah, that's supposed to be the right direction. 1, 1, 0, 1, 0. 0, 0, 1. 1, 0, 1. I mean, it's supposed to be good. It's like an array of vector 3. So, I mean, there's no reason it isn't good. I mean, the only reason it wouldn't be good would be because of the X, Y, and Z. Because if the face is wrong, because at first, like, all of this is 0, right? But if the face is wrong, if we invert things, then... Okay, I might want to... try stuff. So... Wait, 8? Wait, why 8? Wait a second. Why 8? Wait, why? Oh, it's bits, right? Yeah, never mind, it's bits. Yeah, okay, no, that's fine. Okay, what if I do this? And I'll be right back. Boo. Hoping it doesn't crash. Okay, I'm back and there is a crash. Oh no. Oh no. Look at this. So 0, 0, 0, 0, 1, 0. Wait, what is I? It's 1. And this one is 0, 0, 1. Yeah, I mean, I guess it didn't actually change anything. Yeah, I'm just gonna change it back to this. Okay. So there's a problem somewhere else. Let me check comments. Okay. Zero, 1, 0, 0, 0, 1. So let's work at it. Let's look at it in another way. ID. So how can I make the vertex be equal to 0, 0, 1? This times this. Defaults. So I mean, this is definitely not taking things into account. Well, this is definitely not the reason why. Potentially there is a position if z is 1. But I mean, okay, so if we look at this, it's like I equal 1. So that means this I equals 1, right? Because it's like it works 4 by 4. So like ID times 4, right? I'm not setting this again, right? So that means ID is 0. That means it's for the first block. It's for the first phase, I mean. And I is for the second vertex. So it is definitely inside here. With ID equals 0. I equal 1. And there's a problem with this. I mean, because position is 0, 0, 0 because it's like the same block, right? Well, it's the same face. It's the same face. Push constants. I mean, this is not being taken into account because overraise, it would change the first vertex too. So yeah, this is the problem. This is a problem, but for some reason I just don't get it. So I is 1. Let's say I is 1. Let's say I is 1. I is 1. What is this? Wait, so local vertex indices. That's just a copy and paste between the two. This one's my bad. 1, na. I don't see a difference. This is the same picture. And it returns I vec4. X, Y, Z, W. 0, 1, 2, 3, right? So that should be fine. I don't know. So, okay. Then I get I vec4. From the face index, right? Yeah. From the face index. Is the face index computed the same way? Yeah, what is face index? It's just face.face index. I mean, I guess it's like actually from the same thing here, so never mind, that should be fine. Is it because of this const vertices? So okay, let's go there. Code stack 001 instead of 010. Let me write this somewhere. Readme 001. Well, okay. 001 instead of 010. So if I look at this, is this instead of 010 instead of this. So there's like a 1 offset. There's an offset of 1. Okay, so let's go back to here. Boom. So let's say this is face index. Yeah, I don't even know what it's supposed to be actually. It might not even be 0. Wait, I actually can check faces. So for the first one, 0 everywhere. Okay, so I guess it's 0. So if this is 0, this is gonna lead to 0, 3, 4, 7. 0, 3, 4, 7. Okay. So 0. Then we have 3, 0, 1, 2, 3. And this is a 1. That makes sense. What about this one? Let's say this is 1. Yeah, so wait. Face index is 0. 0, 3, 4, 7. Okay. 0, 3, 4, 7. So this is 3. 0, 1, 2. Wait. Face vertex to offset. 0, 1, 2, 3. Yeah, that should be good. So, I mean, the face or something is wrong. You know what? I'm just gonna try with this. I hope I actually don't have to re-import into Godot or something. Like the shader. So if this is 0, technically it shouldn't crash at the first face. Right. So I should be higher than 4. Zero, 1, 0. Okay, what if I... like 3, 0, 1, 0. I mean, it should definitely be wrong now, right? Yeah, I think I have to re-import the shader in Godot in the editor because it's not gonna. Actually, can I? If I'm just modifying the shader, then oh no, I need to check the breakpoint, right? Okay, here we go. Okay. So yeah, it doesn't re-import. Okay, got it. I have to re-import the shader. Oh, that was stupid. That was a loss of time. So maybe changing the order was actually right. That's what I was thinking about. Well, actually, never mind. No, actually, yeah. I mean, it depends if it's like big or little Indian. But well. Okay, here we go. Let's reload that shader. Reimport. Again, just in case. Let's run. And there's a crash. So now what happens if this is... if this is 24, 16, 8, 0. I don't think it's gonna work, but I can pray. Yeah, doesn't work. I hate it. Why can I only debug the shader? Out vertices. Am I checking the right buffer? Wait a second. Because if it's packing... It depends on the packing, right? Maybe it's just a question of packing. So... storage buffer of size vector 3. Times n. I mean, that should be good. Let me look into this. 0, 1. I mean, yeah, there's no reason it's not good. When reading back the texture, is it packed by 16 bits instead? Bytes? Oh, wait. Bytes. A padding, I should have said, but... Wait, if your shader declares an array of vec3 in a storage buffer, you need to account for the layout. Shit. Size in an array 16 bytes. If you allocated this is a bug. Shit. Yeah, okay. Okay. The shader reads the wrong data. Use vec4. Pack manually. Allocate this bytes and write each vector with a 4 bytes pad. Yeah, I guess it does. So if I have a buffer of floss instead, and I prevent padding, would that be more optimized than using vec3s? What are the differences? Pros and cons. Because technically, I guess you can pack if you just use floats, but like, why there's no padding between elements? Cleaner code, natural vector operations. Compiler has an easier time recognizing vector operations. Oh, yeah, right. Right, SCMD. Yeah. Well, I mean, I'm just doing like equals, right? No indexing, less readable. Surprisingly, vec3 is as fast or faster. Yeah. Yeah, because there's the fetching. Yeah, I mean, I should like make a big array. It's right about this. So I guess my bad. My bad. So I'm just gonna go there. There. So to do careful about padding, I guess. So this is gonna be a vec4. This is gonna be a vec4. This is gonna be, I don't know what it's gonna be. The rest is good. I'm not sure about the UVs. What about vec2? Is it padding? Eight. Yeah, there's no padding. Okay, so I guess that's fine. So no vec3. So okay. Now I can go back here. And that means we, instead of having vector 3, we have vector 4. And now we have to be careful because this is vertex data equal this dot xyz. Can I just do this? Or like, I don't know. But I mean, I guess it's, I guess it's something like this. And we're gonna have vertex data 2 equal equal x, y, z. So now I can compare like this, and I can set, and I can do things, and now it should be good and it shouldn't crash anymore. And I can remove this. Yeah, because I guess the code didn't really have any problem in itself, right? So that's why I thought about the padding. And because it was, you know, like there was like 1-1, it was just like offset by 1. So that was a bit weird. Okay. Oh, it's not crashing. Look at this. Oh. Okay, so that was it. That was it. There's no problem anymore. So wait. If I remove this now, is it good? Oh, the vertices. I mean, technically it's supposed to be good, right? Oh wait, I just have to remove. Ah! I guess that's it. I guess that should be it. Okay. Undefined behavior. Oh no. Hi, hello, Sarun, how are you? Welcome, welcome. You're coming at the right time. I finally debugged my thing. Oh, and it's like working, oh my god. What the fuck? I'm doing good, what about you? I suppose I'm good. Oh, it's because I removed the transform, right? Okay. Ooh! Followers goal! Oh, thanks! I appreciate that a lot. Wait, what? I don't think that's supposed to happen. What was happening? Yeah, I guess so. It's because I actually have something crazy. But I removed it for my tests. And now I can bring it back. Let's bring it back! So basically, you see Minecraft, right? It's basically a world that is infinitely big, right? But it's flat. I also play Minecraft, so I played it too a lot. And in the game I'm making right now, I mean, it's definitely inspired. There's like voxel blocks, right? Like voxels that, well, they're like voxels. It's like there are blocks, right? So the world is made out of blocks. But how to say it? It's gonna be crazy, man. Prepare yourself. I'm learning like HTML right now. Oh, that's nice. I suck at HTML. So the UE4 game looks great. Is this for Game Jam? Which one? Which one? Sicaria. It's it wasn't for Game Jam. It was like my graduation project. And yeah, basically this was. Okay, maybe there's like. Okay, well, I mean, it's like a little problem, but that's fine. Basically, the thing is that this is a donut. This world is actually a donut that is slowly getting built, as you can see. And usually I would be able to create like new blocks, like put new blocks and destroy them. I mean, I can fix it like very easily if I want, but I was testing my compute shader. You wanna look at my side or something? I can share it if you want to. I last time someone told me that I had a bad surprise waiting for me. So now I'm a bit more. I'm not really sure, but it's a Minecraft game. Oh, it's not UE4. Wait, what? Oh wait, oh yeah, you mean wait, what? You mean this one? This game? No, it's not for Game Jam. This game is not for Game Jam. It's for, I mean, Steam, I guess, because I want some multiplayer too, and you know, Steam helps a lot about this. I can show. No. I assure you, it's a GitHub site. Yeah, I mean, feel free. Then yeah, sure. GitHub pages, right? I use it too. And yeah, as you can see, it's like a donut, right? And like I can walk and it's good. Everything's good. Yes. Oh, portfolio. Let me see that. Can I show it on the stream? Or maybe not. If it has like your name or something. You tell me. I assure you there's no surprise waiting there for you. Okay. Yeah. Name, age, location. You can use it on stream. It's my nickname. Okay. Okay. I mean, I'm just gonna... It's a bit too late, but... Here we go. So yeah, this is it. Available for select projects, I mean, I like the little... I guess there's a lot of people using AI to make websites nowadays. Like, you know, tools to create them. I mean, I guess you use the template. Or not? I don't know. What? Hey, Diamond Turtle, how are you? What do you mean, what? Hello? What about hello? Say hello! I don't care. Okay. Click on the live demo on the Minecraft one. You'll like it. Live demo. Minecraft Java Edition. Okay. Wait, you haven't... Wait. That doesn't... Wait, what? They don't look like that. They're not supposed to look like that. What do you mean? Minecraft Java Edition. An official fan-made tribute site. Yeah, okay. Yeah, I mean, it's nice. Explore worlds. I didn't have time to use screenshots. I'm sorry. No, that's fine. I'm kidding. Yeah, I mean, it looks good. Wait, what about explore worlds? Oh, never mind. It just brings back down. Yeah, I mean, it looks nice. Definitely. What's bad? What do you mean bad? What do you mean bad? I mean, well done. Looks clean. I guess I do have a website, but it's like really bad. I wish I could have a website like that. I just started coding. Oh, I mean, that's good. Yeah, and I'm just destroying everything right now, chunk by chunk. But that's fine. Yeah, I'm not even sure why he's doing that. I can build it for you for free if you want to. I'm not sure about that. What are you using though? I'm curious about what you're using. Like just HTML, CSS, using HTML, CSS, and JavaScript mainly. Oh, okay. I mean that's good. Maybe I should do that too. I mean, I guess I used static website generators to, well, which are nice if you have like things that look like blogs basically. But yeah. And some ChatGPT enclose for error troubleshooting when I honestly can't do it. Yeah, I mean, I understand. Yeah, I tried using multiple things like Jekyll and other things, but that sucked. That sucked so much. Wait, you know what? I'm just going to copy your link and I might take a look at the code if it's public one day. I won't, but you know. Oh, welcome, welcome. I didn't see that some people joined the Discord server. Wait, it's time for my mew. Here we go. Well, I gotta go sleep. I'm sick. Oh, I'll see you tomorrow if you stream. Yeah, maybe. I'm not sure, but I mean, maybe. Yeah, bye. I mean, if not tomorrow, maybe this weekend, or you know. I mean, I might be here tomorrow night. I just don't know how much. But yeah, see you and rest well. Hopefully you get better soon. Yeah, why is it not getting... Why is it not working? The readback is not good or something? Rebuild mesh. Or is it because of... No, I'm supposed to clear those. So I don't really know why. If it's not prepared, then I prepare. Or maybe it's because of this. Maybe I should like prepare every time again. Okay, so what happens if I run this in the editor? What kind of errors am I going to get? But in any case, it shows that vertices are good, right? So the rest of my data should be good too now. So that means the goal should be to use this data as a direct argument for my vertex buffer. Oh, Grisai! All 5 of his GitHub projects were uploaded yesterday. I don't know, kinda sus. I mean, yeah, I mean, it seems like, you know, if he's like 17 and he just started and he's like building a website, right? Maybe he has like some private repositories or something, I don't know. As long as he doesn't hack me. Let me think. Yeah, let's just run. Okay. So we have this, which is fine or not. That's fine. And when I break, boo. I actually don't have any errors. It just disappears. Woo. Yeah, I don't really know why. But anyways, that's not really a problem. I'm just gonna go back here, I suppose. And I'm just gonna code this instead of this. And that should be more than enough. Well, I mean, that should be enough for now. But the question is, I have all of this. This is okay. Wait. So I'm generating all of this, right? And then I have the compressed format. No. Oh man. I hate it so much. Yeah, I'm gonna have to make my own buffer. Mesh add surface. Sets material. Yeah, I'm completely going out of Godot's base rendering thing. That's kind of a shame, but instance set scenario. Because actually never mind, because even the AABB I'm doing it myself, like the coding, the first time coding. Hey, Robert, what the heck is buffer? What? Hello. Oh, what do you mean? Like you don't know what a buffer is? It's basically an array. It's a big array. That's all it is. I don't know why it's called differently. I don't. Yeah, it's basically a big array. So like instead of one element, you can have multiple elements. That's what a buffer is. And what do you do with it? you Well, it's an array, so you can do whatever whatever an array does with it. I mean, in this context, I guess I'm trying to generate my buffers. So before, I was, I create my chunks, right? And to create my chunks, like the visuals, I create a buffer, like a big array of vertices, right? But I decided to put that vertex generation on the GPU. So now the GPU generates my vertex buffer. And now I'm trying to make it work. I'm trying, I guess the goal now is to connect, to use this buffer created or like assigned on the GPU to my vertex shader. Oh, ads, oh no. Like what? Oh. Oh no, the ads. The ads strike again. Okay. So, oh my god, yeah. So you put the vertices in one array, vertex indices in another array, and the OpenGL draws them. I guess so. I mean, yeah, I mean, it's not OpenGL, it's Vulkan, actually. But yeah, that's basically the hang of it. I also have my UVs and my normals and my custom things. But yeah, that's the hang of it. That's basically it. What are you making your own buffer then for? So basically, well, originally I guess to break blocks. Originally I made my own render pipeline to break blocks because in my world, you know how I have a donut, right? But there's a distortion. Like if I dig down on my donut, it still looks like cubes, right? It still looks like I'm surrounded by cubes. It's like a distortion that I added, and basically it makes it very difficult to break blocks and like to use raycasts basically from the player's camera, because if you use a raycast from the player's camera, it looks like, you know, like the raycast is actually not going to, well, the raycast is going to go in a straight line, but since what's rendered on the screen is distorted, it won't actually detect what the player is trying to click on. So because of that, I made my own pickup render pipeline, which basically detects the block that is in the middle of the screen, like the face that is in the middle of the screen. But the problem with that was that it basically was rendering the scene twice, right? Because my chunks were basically rendered twice. And that's when I was like, okay, let's just make it only one. Let's just render it only one time. And that's why I have my render pipeline now. What do you mean? You got projection matrix for that? No, it's not a projection matrix. You know what? I'm going to show you. It's better to just show you. I just have to remove my thing so I can show you. And actually, that might already be good. Rebuild mesh. Yeah, it should actually be good. You're saying ray is not going in a straight line. I mean, technically the ray is going in a straight line, but not from the player's camera. Not from the view of the player. Okay, let me, in the meantime, while it's starting, just checking editor, good. I'm just gonna try to create my own vertex buffer. Oh, here we go. Maybe I should have asked ChatGPT first instead of torturing you. No, I mean, ChatGPT wouldn't understand. So I mean, it's good. And I'm glad to showcase the game, right? Because like even like technologically wise, I like it a lot. So So pick up. Let me just remove this. Where is it? Wait. I think it's this. Okay, let's try it. So, this is my world, right? This is a donut, right? But right now you can see the problem. The problem is that my blocks are rectangles. And this is due to the fact that if you have a donut, let's say you cut a slice, then you're going to have this. And as you can see, you can't have cubes like this, right? Like even if like it, at first it looks like a cube, you know, the deeper you go, the more and more it's going to be a rectangle, right? Because of the nature of the shape, right? This is a problem. Like if you dig down, like the more and more you dig, the more and more it's going to be like very, very, very like this. Not rectangle, just some shape. Yeah, but I mean, yeah, you know what I mean, right? And like the more I'm going to put blocks like this, the more and more it's going to look like a cube. But I think there's going to be like the limit first. I'm gonna reach the limit. Actually, maybe not. Yeah, now it almost looks like a cube, right? Oh, it's getting wider. Yeah. Because it's supposed to be a cube on the surface of the torus. But like right now, my torus has like a very big possible eighth. So that's why it looks like this on the surface. Right now it's like a cube. Now it's a cube. Right? But because of the nature of the torus, when I dig down, it's getting thinner and thinner. Right? So yeah, that's the problem. So because of that, I basically have... I basically have a vertex shader that's moving the position of my vertices. And now it's a cube. Now I have cubes, right? And like even if I dig up, it's still cubes. Right? It's still a cube. And if I dig down, how? Right? And if I dig down, it's the same. It's a cube. I still have cubes. Right? It's like cubes everywhere. Right? You know it's impossible. You just proved it. Yeah, I was like, yeah, why keep this if I don't like it? So I just changed it, right? And I still have a donut. As you can see, I can still loop around. Like, let's go very fast. And you know, it's still cubes, right? And now I'm gonna finish my loop very soon. Here we go. But how? Magic! I'm a magician. I'm actually a magician. It's actually a bit complicated. But you deproject them or something. Yeah. Basically, So basically by default, you can see the world as being flat, okay? But then you have some transformation that can turn it into a torus, into a donut. But then what you can do is locally you can untransform I mean, it's not very optimized, and I'm gonna change it in the future. But you can basically turn it back into an Euclidean flat world locally. Locally you can turn it back into an Euclidean world. But then you have like some kind of transition, like interpolation, that slowly turns it back into a donut with the distance. There are still pizza slices in reality. I mean, there's no reality. There's no reality. I think that's the best way to say it. Well, it should be reversed donut or something. Reverse donut. Yeah, I mean, yeah, I see what you mean. The transformation is like a reverse donut. You can see it like this, I guess. And it's just I guess I'm just switching between Euclidean and donut worlds. But you know, like people ask what it is in reality, like what shape it is in reality, but there's like no reality. Like behind the hood, it's you know, I have my chunks that are organized in you know, it's like a 3D array basically. But then, like, depending on whether it's used for collisions or for rendering, it's like going to take a different shape and it's going to be at different places. So there's no like reality thing. The only reality is that it's an array, it's a 3D array. I mean, still a donut, but not donut turned inside out. Why? Why not? Because it's only locally that it's Euclidean. Why do you mean why? And I mean, I'm also taking into account the position of the player when I'm untransforming the donut. I don't know. So basically, I'm like, for example, when I move, it's always going to be flat relative to the player, right? Because the player has like the forward, up, and right basis vectors, right? And you basically untransform the donuts based on those axes. What if there are two players? Well, if there are two players, it's always going to be according to the view of the camera. So, like, if another player is on the other side of the donut, I'm just gonna see this player there. Did you come up with the formula? I mean, I used ChatGPT to help me with some stuff, but ChatGPT was definitely wrong about it. So I did have to dig a lot myself. I would say... I would say it's kind of like a mix. Because, you know, like I had to, you know, be the one to think about like where to use the transformations, for example. And like the donut transformation is like pretty simple, right? Like you can see that on Wikipedia. You have the formula on Wikipedia. And like to untransform the torus too. Then, well, I mean, I guess it was kind of complicated to... I mean, I still have the interpolation wrong, actually. I still have to fix interpolation. The projection thing, it must have a name. If it's a thing. I mean, I think you can call it... it does have a name. Like, I mean, you have the... I mean, like, matrix-wise, you have something called the Laplacian that tells you the vectors. Like, that gives you a basis that is orthogonal for a given point in a space. That is not necessarily a Euclidean. But then you also... How is it called? I forgot. But yeah, there's like a tangent space, I guess. I don't think it's really this. I mean, technically... technically you can see it a bit like this, right? It's basically kind of similar. How do you code it when a space is transformed into a Euclidean space locally? I think a manifold, no. It's not a manifold. I mean, of course it's a manifold, but everything is a manifold. Locally Euclidean. I forgot the name, sorry. I still don't understand what basis is, to be honest. Oh, a basis is like the basis of a referential. So like you have vectors in your referential, right? Like for example, in this space, you have the x, y, and z basis that defines the space. Well, it defines. Yeah, you can define like things from this, like the rectangle. Well, it's not a rectangle, but I just don't know the name in English. It's a pavé droit in French. But yeah, you have this, for example, right? You have basis. But then you can have different spaces. Like distorted space, you can say. Basis. Axis. Well, axis is a basis is an axis. Well, basis and axis is like the same thing. Math. Transform space. Non-orthogonal space. So yeah, for example, you have this, right? You can have spaces that are not orthogonal, and in this case, you have like the axes that are not, that do not have a straight angle. You have this, I guess. It's fine, Godot objects have basis. Oh, well, it's just the axis, basically. It's like usually it what defines the direction of the shape. Like you have a forward, you have a right, you have a up, and like if you rotate the basis, then you rotate the object, and if you scale one basis, I guess one axis, you scale the object too. Not 90 degrees. What do you mean by that? Yeah, it's not 90 degrees. Yeah, this is not. Well, this wasn't. Wait, not. Well, in non-orthogonal spaces. Yeah, you're right. It's not necessarily 90 degrees. I really don't know. Wait a second. I'm gonna ask ChatGPT. How do you call a space a math space that is Euclidean locally, but the manifold is not? Give me all possible names. I mean, in my case, I have like a flat torus. But that's not really the question. I don't know, man. I'm sorry about that. I didn't get it. Tangent space. Yeah. It's not really. I'm using the tangent space of the player, but it's not really like what I have is not really, you know, the result is not the tangent space. Genius. Oh no, you forgot to tell it to make sure to make no mistakes. Oh, you're right. But yeah. It has like a stupid name too. I really want to know what it is. Wait, What about the thing you told me? Well, what about the thing I did with my distorted space? You told me it was something special. But I forgot the name. Give me all possible worlds. I go for some time now. Oh no, thank you, you're welcome. Perpendicular orthogonal. I mean, that's not really the word I'm searching for, but no, no, because oh, I guess you have the metric tensor. But that's not really what I want. I do want to copy this though, because this is a nice thing to know. Geodesics, not really. Okay, if you want, Hyundai, I'm gonna show you what I was talking about, but it's not that. You know, I have my space, and basically, even if it's a donut, I can dig into the ground, and it's still going to look like cubes. Right? Even though logically it should not, because it's like it should get like smaller and smaller the closer you get to the center, but it's not, as you can see. And now we're basically reaching the center. This is the center, and it's like a cube. So the question was, how is the bubble around the player called that is making things orthogonal, and like not orthogonal, but orthonormal. How is the bubble around the player that's making things look orthonormal called? It's a chart. It's a chart. It's a chart. That's the name. It's a chart. It's a local chart. I think that's the name. I don't know what it is actually, but yeah, I think it's a chart. Space. Like math. Wait. Is a mapping that allows you to translate complex curved geometric shapes, manifolds, into flat familiar Euclidean space. Kind of. Well, maybe it's not. It's defined as a homeomorphism. No. Okay, it does look a lot like this, right? Orthonormalized vectors. I mean, you can. I don't know. I would say it's like, you can say I'm using a chart. Because I'm well, yeah, I'm transforming to translate. Yeah, I guess technically you can say I'm translating it. Well, yeah, translate as in translation. I mean, yeah. I'm transforming my manifold into a flat familiar Euclidean space. It's like a local chart. So it's only about what's around the player. Kind of. Maybe it's not. Maybe it's not. It might not actually be that. Well, it's something. It's a transformation. You know what? It's just a transformation. I just have this donut, okay, and that's it. That's it. So what I wanted to do now was I have the rendering server, but I think I want a rendering device. Do I have this? I do. I do be-do. So right there. Let's get it. Let's get it. And I'm gonna create buffer. Like vertex buffer create. That's gonna be a pain. Donuts, I like donuts. I like them too. I like sugar. I like sweet. So I actually don't know at all what to do with this. And when we don't know, what do? We ask for help. Help! Help me, GPT. Wait. Can you go back to this discussion? And this is gonna be Godot. I'm trying. Oh, there's no music anymore. It just finished. Ooh. So I'm trying to create my own vertex buffer for my custom render pipeline. Should I store? Well, can I use? Well, how can I use that? How can I use different buffers as a single vertex buffer, kind of? It's not a single vertex buffer, but well, it's not. But yeah, okay, it's gonna understand. Create each buffer instead of one interleaved buffer. Yep. Describe the vertex format. So okay, how can I create those though? Bind all buffers. The shader then simply read. I mean, I know. Separate buffers. What? I mean, yeah. Yeah, all of this is good. For voxel engine, For me, the code. And could I use create, well, vertex buffer create? Create them, bind them as storage buffers. No. Create the vertex format. Okay, so this is what I want. Okay, so that's what I was missing because I was using the vertex buffers and stuff from Godot. So different attributes, different vertex attributes, vertex format create a vertex array. And then we have the vertex shader. Extra work is needed. So driver fetches each attribute from the correct buffer based on the vertex format. Or what? Compute shader. The next part is that the same buffer or ID can also be bound as a storage buffer. Yeah, this is good. This is great, man. I like that. One caveat for vector 3. Yeah, I mean, vector 3 is fine. I don't... Wait. Actually, wait a second. All right. Oh, no. Oh, no. You have a few options. Wait, that sucks. Right, positions as vec4. And use a 16-byte vertex right. Yeah. Attribute format. Still this. Or write positions as a packed float. I mean, this is what I was thinking about in the compute shader. So the layout is 12-byte contiguous, matching a 12-byte vertex stride. For GPU-generated meshes, many engines choose the first approach because 16-byte alignment is convenient and efficient. But it's like so much more memory though, for like Minecraft, for like voxels. The vertex fetch simply ignores the unused fourth component. If your shader declares it like this. But I'm making a voxel game with a lot of chunks. Wouldn't it be, well, isn't memory important in this case? Wouldn't it be worth it by a lot to use 12 bytes, right? Storage size, memory bandwidth. Suppose a chunk has all of this. 12 bytes, 16 bytes. Difference. Ooh. If you have 100 visible chunks, that's significant. Yep. Should you use vec3? Nope. Well, don't use it. Yeah, I know that. Don't store positions as float at all. Instead, they store something like this. Yeah, I mean, that's not wrong. I mean, I can make it like even smaller if I want. Hmm. Mm-mm-mm. Or even this. Yeah. You don't need all of this. Yeah, I know. Everything fits. Yeah, I know. And that sucks. I just realized, but I'm going to need the transformation. If I want to change... I need the donut transformation if I want to change the vertices directly. AI is better at answering questions that already have answers. Yeah, I guess. Usually scattered over the internet. Yeah, I mean, I'm using it as some kind of Google, right? It's like Google. It's my little Google GPT, because else it starts hallucinating. I mean, I suppose. But that's like the kind of thing that is pretty much on the internet. So that's not really a problem. And I mean, you know, I'm like using critical thinking. I know that's crazy nowadays to hear that, but I'm doing it. And I mean, it's right. What I wanted to do was actually, I didn't even want vertices in the first place. I did want to keep my well, I guess I do want to transform the... Yeah, okay, never mind. I want to cache the vertices. Yeah, that's what I'm doing. This is fine. Though I guess technically, like the plus chunk position, all of that. I can technically... How to say it? Yeah, I could optimize the memory, but I mean, it doesn't really matter right now. Yeah, it doesn't really matter. What really matters is... Wait, let me just check this. Packed positions, packed attributes, XYZ, and yeah, I mean, okay. It's trying to teach me about optimization. I mean, what I really want right now is to create my vertex buffers, and then I want to bind them. I speak from talking to my AI chiropractor. Oh, okay. I actually don't know how to pronounce that. But yeah, I mean, I worked on AI myself a bit, so I know how it works, partially. Well, good enough to, you know, to I'm gonna say to understand, you know, how it works overall. Whenever it's like diffusion, LLM, well, LLMs mean so many things, like transformers, RNNs a bit, that kind of stuff. I just don't know where I'm going to. I think it's like when I create my pipeline, I need the formats. So create a vertex array. I mean, technically, I can have the formats be here. So let me go. There. Okay, so instead of this, if I have something like vertex buffer create, oh right, right, okay, never mind. Okay. Oh, yeah, I understand for the compute shader now. Oh, you done Claude? I haven't used Claude actually. I just use Gemini, GPT, and I use Copilot a little. But I mean, it's not really changing anything much for me with how I'm using them. So yeah, I can just create this. I guess in my case, okay, let's turn it back into vector3. And instead, I'm gonna have this. Okay. So this is going to be a vec3 out to vertex. Boom. Something like this. And this is out to vertex. That x. Like I guess 0, 1, 2. And we're gonna have +1 and +2, I guess. And the same for normals. Oh, I'm not using normals right now. Yeah, this is fine. Let me take a look at vertex formats again. So location 0, 1, 2, offset, buffer index. Right. So it's the buffer index. Index, then create a vertex array. You have this. And yeah, you have your 3 different buffers. Okay, this is fine. This is good. So I'm just gonna test this. I just wanna check. Create vertex. Well, vertex buffer create. I guess I don't even need a flag. In this case, why not? And I'm just gonna go back there. Why not there? There. And yeah, this is not going to be a vec4. This is going to be a vec3. No. Boom. And I'm... Oh, right. I'm just gonna test this. But yeah, what about you? What have you done? What have you experienced with AI? And even without AI, what did you do? What do you do? Tell me about you. Oh, comments. Yeah. Okay. So right now I'm trying to test if I can use a vertex buffer created like that without any problem with my compute shader. That's a goal. Wait, I actually have my float. Yeah, that should be good. Wait, actually it's not. No, it's not good. Ah! Like this times 3. Yeah, that's the same index, I know. But that's basically it, right? So now I'm gonna try re-importing this. And let's go. I use Godot and do use AI to answer a quick question, a specific question, but not to generate code before I used to. Or before I used to. I see. Yeah, I mean, I don't really care whether you use AI to generate code or not. As in, I mean, I guess I'm interested in your workflow with it if you do, but you know, I'm like not judging or anything. I guess in my case, I do like making the architecture myself and stuff, and I'm not like letting AI write all that because it feels like it's not gonna do what I want. Or it's gonna need like too many things to do it like I want. Because I mean I type fast, right? Well, maybe not that much, right? There's AI, but yeah, like right now, writing the code itself is not really it's not really the bottleneck, I think, for my work. I have a character controller that can hold items, probe them, and make sounds with each collision. Oh, I learned to do this without generative AI, that's good. As I'm a beginner, although my sound collision is not there yet. And it's still nice. And yeah, it seems to not crash. I'm just gonna check if I'm actually... Never mind, it's not even being used. Let's do this. Eight. Yeah, I'm gonna have to go soon, sadly. I just really wanna check this, and after that I'm gonna check this, and after that this too. Maybe not. Vertices or ID. Yes, so okay, I might prepare my format. So create formats, vertex format. Let's go there. Let's run this. And it's crashing shit. Was not created with storage flag. Oh, that's why. Okay, so I do need this. I do need the storage flag. That's what I was thinking about. So data is this. And buffer creation bit. As storage bit, I guess. Is it like RD this flags equal as storage bit? Boom. If I restart now, should be fine. I hope. I hope. And I'm gonna continue my vertex format thing in the meantime. So, where is it? Yeah, because basically what I'm doing here, I kind of did it already with my custom engine and like rendering and stuff. But I'm just not sure about the syntax because it's not like OpenGL like I did. It's like not even Vulkan. It's you know Godot, right? So there's like some unknowns with it. But I can still navigate it because I know what's like the different classes and stuff are about. So in my case, it's not gonna be positions. Well, it's like vertices, right? Location. You know what? That's going to give me the same problem as before. It's a ref counted, right? So in the end, I want RD vertex. Well, I want this RD. Let me actually check if this works or not now. Shit. I mean, there's no error now. I think it's just a crash. It's very good as well. You're gonna learn a lot more. Wait. Sorry, what do you mean? What was the context about that? I don't I don't remember. You mean like using AI for like Godot? Like by knowing like some kind of stuff? Or like yeah, it's not working though. It's not working anymore. Okay, I'm gonna try restarting like this. Okay. This project is very good. You're gonna learn a lot. Yeah, I agree with that. That's also why I'm doing it, because like even just about math, like I feel like I've learned so much, and like yeah, I like it a lot. You know, like with distortions and stuff, and like it makes me practice like architecture too. Yeah, okay, so that was the place, and 1 is the difference. Oh yeah, of course vertices are different. Because I transformed them. 0, 1, 0. Yeah, okay. No, okay, this is good. Okay, it's actually working. Never mind. It's actually working. So that's great. Okay. So I mean, there's no more errors now in the editor. Wait, let me just run it. I don't actually have to run it, but yeah. Just to have it open just in case. And And yeah, I mean, there's like so many things I want to do too. It's like format create, vertex format create, probably. IntelliSense, please. Oh no. Yeah, now it's like just telling me that I'm wrong because I saved. So let's do this. So yeah, it's rendering device commons vertex attributes. It's not RG vertex attributes. So, and it's a vector. Vertex attribute. I think that's the same. Yeah, it's like commons. Yeah, okay, that's good. So attributes. So GPT is wrong about this, for example. He's like always using the wrong types because they're so similar. But that's fine. You get used to it. Push vertices. So yeah, it's gonna be this. And now we have a, here we go. So format, what is format? I don't know what it is. No. Binding. The index of the attribute in the frequency. Huh? Huh? Wait, you can have that? I guess you can. Data format. Oh. Okay. I like this. It's for colors though. It's for colors. And data format max, what is that? You're just not using anything, is it? Or like, I guess I want the something. Anyways. Aside from this, what do we have? Offsets, location, stride. Yeah, what about the vertex attribute binding? Wait. Yeah, it's afterwards. Right. Frequency buffer index. Yeah, I don't have a buffer index. What is that? RG vertex attributes. If I go in, oh, I think it's like location. Is it? I actually don't know. Doesn't have. Actually, it does have. Well, doesn't have buffer index. I mixed up Godot and Vulkan. A. Determined by the order of the attributes and the order of the buffers you pass. What? Position normal. Oh, I mean, I guess, yeah, it's gonna be a single. Wait, how can you specify the buffer though? Does not expose Vulkan's multiple vertex binding functionality. Oh no. Oh no. A single vertex stream. Oh no, that's bad. Oh shit. Mm-mm-mm-mm-mm. That's bad. So, I mean, I see, I can still have multiple buffers though, right? It's just that I can't specify it. It's just determined by the order. I think it's fine. It's determined by the order. Can I still have two attributes interleaved? That's how you call it, right? And another not interleaved. I don't remember the name. Buffer interleaved. Yeah, I guess it is. Maybe not. No? So UV attribute will need to reference a different vertex binding. This is bad. This is bad, chat. What layouts are possible? Interleaved. Separate. What? This depends on how... nah. Wait, the binding... Wait a second. It already has a binding field. Is ChatGPT saying bullshit again? Yeah, it does have... It has binding, location, offset, formats, right, frequency. So yeah, technically it should be good, right? Oh my god, GPT, what are you doing? And yeah, you can do exactly what I... Okay, yeah, I was afraid. Yeah, I'm just like it's binding and location. It's like differentiating the two is a bit difficult. Location 1 and binding 1, location 2. Where this Position normal. So if it's in the same location, so binding is the same binding, but location is like one up. Okay, I get it. Okay, so if I actually want things to be good, I actually want, instead of creating so many buffers, wait, do I want my index buffer to be apart? To be on its own? I mean, I'm not sure about this. But I guess what I want... Okay, I'm just gonna finish with this, kind of. I'm gonna have... one vertices buffer to optimize depth map. Well, to optimize performance for depth map. Gonna be great with lights, since they need depth maps too, basically. So this is kind of like needed. And then we are gonna have a one interleaved buffer for everything else. That's basically what we're gonna have. So like normals, UVs, well, for the rendering. So we are gonna have normals, normals, UVs, custom 0 RIDs, custom 0. Triangle indices. I'm not sure about the triangle indices. Should I have the indices in the same buffer? Because usually it's like a separate buffer, right? It's like the index buffer. So yeah, it should be its own buffer. Okay. Okay. So I'm gonna have one index buffer then. Indices, like triangle indices. And this is actually, I actually don't need this. Like, this is actually not something I want, because that's something I'm using on the CPU to wait a second. I mean, technically, if I'm doing the pickup, I'm doing that on the GPU, right? So technically I could do that on the GPU too. But like, isn't it like a bit overkill to run a compute shader just to sample one thing? I mean, I don't even need this, I think. But yeah, okay. Then we do not send this and this to the shader. Here we go. Okay, here we go. Vertex format creates. So we have the new format. Poo, RD. And I guess that's it. So basically we are going to have 3 different buffers. We are gonna have RD create. Well, actually, not really, but well, yeah, okay. Attributes. Right. Vertices. Binding 0. Location is 0, so it's location, right? So binding should be the same for those. Then we have offset is 0. Stride. I mean, wait, technically. Oh, wait a second. Oh. Technically, I can create a big buffer where the offset. Oh, I can make it in. Oh. Wait a second. So. Okay, let's ask GPT just for performance. Instead of different buffers, can I just have first? Can I have a big buffer with vertices at the start, not interleaved, normals, UVs, etc. afterwards, interleaved? Technically I can. Performance-wise, is it better? Since it's keeping vertices locally in cache for depth maps, but locally close for depth maps, and it's only changing the bindings one time for each draw call. Well, not for each draw call, but yeah. It's actually the best. Several effects. These shaders often only need this, the and fetched. Well, performance. Okay, so prepass shadow map. So this is ideal. This is good, I guess. Main pass. Fetches from both regions. This is good. Cache behavior. Is it? Written by one kernel, while other kernels feel this without touching the position data. I guess it's only changing the bindings one time. What? Oh, I guess I do. Positions. So is it like wait, UVs? There? Why there? Wait, what? Packed extra? Oh yeah, you pack it. Yeah, I mean I do want to pack, of course. Ideally. Optional. UVs. Oh, optional. Oh right, you can have optional data too. Position only passives touch only the first section. Most geometry passives fetch only positions plus packed extras. Expensive or rarely used attributes live in their own regions. I mean UVs and tangents. I mean in my case I'm using UVs though. Compute shader can generate each section independently. Not really. I do want my UVs. Allows the same. Wait, do I actually need UVs? I think I can actually compute UVs from something else. Oh, sorry, I didn't see. Hey, repeat. Wait, what did you say? If I use OpenGL, is it custom render pipeline? I guess. I mean, it depends what you do with it, right? You can you can create a custom. You can create a pipeline with OpenGL, and if you do that, it's a custom render pipeline. But like, if you use OpenGL to, for example, upload vertices to the GPU, then technically you're just uploading vertices because you don't have your pipeline. You've been streaming for 7 hours almost. Eat some ice cream. I should. It's actually gonna be 7 hours in like 20 seconds. It's like 2 a.m. 30. Yeah, I mean, I have to start work early tomorrow, actually. So I'm really going to go. But first, binding location offset. Yeah, I guess I want everything to be in the same binding. So formats, stride, and frequency. Formats, stride, and frequency. I'm just writing everything so I don't forget, but I don't actually need everything. Like, I mean, I guess I'm gonna need the format, but yeah. So offset is 0. Right, location is this. Offset is 0. Stride is size of vector 3. Right, is it? Wait, is the stride the... Wait, I'm not sure about this. 0 by default. is a stride, and if I have a buffer of vec free, is the stride size of vec free? Or is it 0? Okay, I guess so. No. Okay. So we have this. That's a to do. Then we have kind of the same here with like boom. I mean, I don't even have normals right now, but yeah, that's fine. So binding is the same, location is 1, though. Offset is gonna be... Oh no. I mean, technically it's the size of... Okay, it's actually a bit complicated. Do I need the format ahead of time? That's the question. Because I guess the problem, if I want to put this after the normals, is that I need to know the size of the vertices, right? If I want to put the normals after the vertices. So, okay, in this case, it's actually not really possible. So binding is 1. Offset is 0. Stride is something. Plus size of vector 2 because of UVs. Plus size of floats. Yeah, wait, I'm actually not sure about this anymore. Customs. Yeah, let me just take a look at constants. Oh, I'm not even using customs anymore. I forgot about that. I'm not even using oh. Oh no. So I guess I don't even use this. Okay. So technically this is it. This one is something like this. Binding 1, location 1 though. As the offset is gonna be vector 3 because we have the normals before that. And the stride is gonna be this. And then we have the format. And you know, maybe the frequency, but not really, right? So I mean, I guess format, I can set it right now. Like, oh, well. Data format. Oh. Well, it's just UVs, really. I mean, in my case, I just need like 0 and 1s. I don't even need the UVs, I think. I'm not sure. Maybe I need them. Yeah, I can't get it from the face only. So yeah. So R, and I guess I can have R8. I mean, I could like even, I could like make it very small, make it more compact if needed. So R8, because technically it's like 1, 2, 3, 4. There's like 4 possibilities, right? So it's like 2 bits. Only needs 2 bits. 4 possibilities. Only 4 possibilities. R8 uint. Maybe. I mean, I guess it's supposed to be flats, but wait, R8. SNOM. What is SNOM again? It's signed. What about unorm? I guess that's how it should be. But yeah, I'm not sure about this. I mean, I guess it's like extra, right? Should be put in extra, maybe. And fused back with other things. Something like that. With other data. Like we have, I mean, I guess we do have the IDs of the faces, but yeah. So I mean, we actually don't have a lot of attributes right now. I'm realizing. Oh, we do have the, wait, the texture. What am I using for the texture? So position, I'm definitely using this. In color, I'm not even really using the color anymore. UVs. Okay, I mean, fine. Then we have the elements ID. Oh wait, this one is actually important, isn't it? uint. Yeah, it's a uint. It's a uint. So wait, what am I using for the in UVs and texture ID? So wait, what's the texture ID? 5. Face. Wait, what? Oh, because I'm re-uploading the textures. Wait, what? Wait, that's kind of bad, isn't it? Is it? Actually, no. No, it's a uint. Right. 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 Right, so it's like not changing. Why not? That's a possibility. It's not that bad. And yeah, it has to be a uint though. So I mean, element ID, well, it's like face ID. I need face ID. I mean, I already have a buffer actually for that, right? Because that's what I'm uploading in the first place. There, right? So I mean, that's good. I already have it. So wait, face 1, 2, 3, 4, 5, 6, right? No, it's not. Element. Well, yeah, it's not from 0 to 6. It's like the whole. It includes the information about the block. So it's like face. Wait. That's a bit different though, isn't it? Because this one is storing the faces as XYZ, and the other one is storing the faces as like 1, 2, 3, 4, 5. Right. So I can't use this for like its face indices. And face indices, let me think 50 times 50 times 50. It's out of this. And if I do so let's say we have I don't know. O times 6 for the different faces. And then we have what was it? 50. Yep. Yeah, okay. So memory wise, if we have 2 floats, it's like 8 bytes. I mean, yeah, it's 8 bytes, okay. What about it? Wait, what about it? I forgot. What did I want to check with my 8 bytes? If it was fitting, but... Right. Right, so it's not about this, is it? No. Okay, yeah, I get it. So 8 bytes. And that means it's like 2 power 8. 256. Um, yeah, that sucks. Wait, 2 times 8. No, that's 1 byte. 2 times 8 is 1 byte. So then I want to multiply by 4 because it's like, well, that's gonna be a float. So 2 floats is this. Wait, what? That's not really. Yeah, okay. Yeah, okay, that was the question. So if I do this, it's like a lot less, right? So if I have 1 R, I have this. 1 R 32. And that means that I can store my UVs because it's only 4. So it's like this. I could store my UVs with my index, well, face thing. I'm just gonna note this. Oh. Store, well, fuse UVs with face index. Mm. Mm-mm. Mm. So let me just look at this, not this. This, if I do something like bam, bam, bam. Wait, that's crazy though. It's still like more than fine. Yeah, the chunks are like, whoa, it's like working well. And the outputs, yeah, okay, the problem was because of the chunks, right? But that's in the outputs, and I can write in the pickup output texture easily. Okay. I mean, I can put even more things then in this. If it's like a R32. But, okay. Let's have this. And yeah, instead of customs, it's like face indices from 0 to NV faces. It's basically binding is the same. Location 2. It's just a uint 8, just a byte. So I guess we need to increase size of this. Oop. And then we have this. Oop. And offset, well, actually the offset is this, right? Technically. So format is data format. Oh wait, I think even if we have like uint, it's actually not compatible. That's why I was using float. That's why I was using floats. But okay, let's just keep this for now. I mean, okay, for now I'm just gonna use the default data format or 16 unsigned normalized. Wait. Trace indices up to 256. That's not a lot, isn't it? Hey, praise to version control, which allows me to try shit and go back without regrets. Yeah, like my best thing to... Like, if I work with people that haven't used version control before, like artists, what I like to show them to, you know, show them that it's nice, it's just I remove my whole project. I just destroy everything in my project. And I just, you know, do a few comments and, hey, look, it's back up. So yeah, don't worry about fucking things up in the project, because we can always go back. And you know, the goal is to make them like less afraid to touch the project, because sometimes, like for artists or for like other programmers, I don't know, like sound designers, for example, it's like, you know, a bit scary, right? Because they're not very familiar with the thing. But if you show them that there's no problem if you make mistakes, then I feel like it's a nice way to make them more comfortable. Wait. Data format. Oh. This maybe? Unsigned? Is it? Float. Signed normalized. I want to inspect a node while moving. Is it possible? What do you mean? Sorry, my brain is like really at low capacity right now. While moving, like your character is moving? Or like, are you dancing on your chair? Are you like turning like this? Like, woo. I have actually my headset, so I can't do that, but woo. What are you doing? Like when the game is playing. Yeah, oh yeah, that, okay, I get it. Yeah, you can actually do that. You have so you start your game, right? And you have the remote here. So local is basically, you know, your project. And remote is basically what's, you know, it's the game being played. And you can check like your player and stuff. And you can modify that if you want. I think it got added pretty recently. I don't know if it's like a Godot 4.345. One of those. Data. Data format. Wait. Data formats are 8. Not at all. I feel like it's not really needed, but actually maybe it is. Well, it depends. Well, actually. Technically, it can just be integers. Kind of. So, signed plots. Sounds good to me. And yeah, I can definitely optimize this, but this is gonna be a job for another time. First, we have to make it work, right? We have to create our formats and stuff. So I'm gonna tell myself in the future, because I'm a bit too tired, I'm gonna tell myself to do, you have to create the different vertex buffers format and use them for your own render pipeline. Make it work, please! Okay, here we go. And now I really gotta go because it's 3 AM already. It's gonna sting a little, but yeah. What can I... Wait, who's that? Never mind. Yeah, there's no one today on Godot. That's crazy. Who's this? C#? I mean, you can always... It's pissing me off that line 2D is so hard to make it relative to parent. Yeah. Yeah, I feel you. Okay, let's go with Minecraft. Should we? Unity, game dev. Oh. That's not Unity and that's not game dev. Are you making a class for animations kind of like sprite frames? A class for animations? Wait. Oh, never mind. That's a that wasn't my chat. Okay. Yeah, I mean, I guess that's gonna be it for tonight. I'm just gonna run this little raid. This is the... It seems to be someone streaming some Minecraft, but they also have like some game dev and Unity tags going on. So, game dev, I guess. They have itch.io. So yeah, just thought we would raid. And that's it. So thank you a lot, everyone. And I'm gonna see you next time. Hopefully we can, maybe not finish, but almost finish it. You, peace. Ooh.